If Facebook is the who and Google is the what, then remote sensing is the where. A very warm good morning to all the respected dignitaries, our chief guest for today, guest of honor, esteemed speakers, deans, head of the institution, faculty members, research scholars, students, and participants across the country. On behalf of Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, and Indian Meteorological Society, IMS, New Delhi, I, Dr. Amrina, along with the entire organizing team, welcomes you all to an extremely knowledgeable and insightful orbital voyage of 3-day workshop come training program on climate modeling and remote sensing applications for environmental systems. Ladies and gentlemen, कवि दुष्यंत कुमार जी ने कहा था, कौन कहता है आसमां में सुराख नहीं होता, एक पत्थर तो तबीयत से उछालो यारो. Ladies and gentlemen, the time when poet Dushyant Kumar ji wrote these lines, he had no idea that our satellites and signs will go beyond the zenith and will reach to abyss or core of the planet. The skilled mind and extraordinary intelligence of great researchers, scientists, and academicians have given us remote sensing, the science of where. Today, we are here to develop an understanding in the field of climate change modeling and remote sensing applications, and also how to assess the use of climate research findings to address the problem of environmental system with available tools and technologies, particularly remote sensing and its application. I now begin the blessings of Almighty, the lighting of the lamp that signifies the acknowledgement and blessings. The lighting of lamp removes darkness, ignorance, unhappiness, and symbolizes abundance, prosperity, and knowledge. May I humbly request our guests to participate in the virtual lighting of the ceremonial lamp before starting today's proceeding. Now I request Mr. Naresh to please play the video.
शारदे माँ अज्ञानता से हमें तार दे माँ. मुनियों ने समझी है गुणियों ने जानी, वेदों की भाषा पुराणों की वाणी. मुनियों ने समझी है गुणियों ने जानी, वेदों की भाषा पुराणों की वाणी. हम भी तो समझे, हम भी तो जाने, विद्या का हमको अधिकार दे माँ. हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ. हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार शारदे माँ, हे शारदे माँ, हे शारदे माँ, अज्ञानता से हमें तार दे माँ।
Thank you so much, Mr. Naresh. May the God's blessings keep showering on us throughout. Ladies and gentlemen, when we began this journey with the pixel idea of organizing this workshop come training program with IMS, we had no clue that we were going to have the galaxy of eminent speakers sitting across and sharing their elements of knowledge with us. Ladies and gentlemen, with all humility, I invite everyone to the curtain raising ceremony and share the glimpse of our inspirational team and galaxy of eminent speakers for this 3-day event. I request Mr. Naresh to please play the curtain raiser. Thank you, Mr. Naresh. Moving ahead, ladies and gentlemen, it is a saying in our culture, Atiti Devo Bhava, which means guests are equivalent to God. So before we start our session, we would like to felicitate our guest with Tulsi sapling, symbolizing the friendship, the growth, the synergy of passion and compassion, and to serve humanity, mapping the same values, culture, concern, and ethos together and forever. Now I request Mr. Naresh to please share the video for virtual felicitation. Our Vice Chancellor Ma'am is presenting a Tulsi sapling to our Chief Guest, Dr. M. Ravichandran. Our mentor, Amity Institute of Environmental Sciences, Professor Bandyopadhyay, is presenting a Tulsi sapling to Dr. Mrityunjay Mahapatra, the guest of honor for today's event. Our program convener, Dr. Renu Dhupar, is presenting a virtual sapling to Dr. D.R. Patnaik, sir, who's been a constant inspiration for us throughout this event. Thank you so much. I now request Dr. Renu Dhupar, Joint Coordinator, Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, to welcome our guests and participants and introduce the aim of this workshop.
Thank you, Dr. Amrina Sadaka, for introducing me. Thank you. Very good morning and namaskar to all, and very happy and prosperous New Year. I, Dr. Renu Dhupar, extend my warm welcome on behalf of Amity Institute of Environmental Sciences, Amity University, Noida, Uttar Pradesh, and Indian Meteorological Society, IMS, New Delhi, to greet and welcome to all honorable dignitaries, chief guest of honors, participants, and my dear colleagues and staff members for joining us in inaugural sessions of 3-day workshop cum training program on climate modeling and remote sensing application for environmental systems. Environment systems are important to monitor and control with the rising concerns of climate change and weather events. Climate modeling has become imperative to predict future events. The growing human impact on the environment has led to the development of new observations and analysis tools to tackle and monitor types, magnitudes, and rates of environmental changes. Timely observations by Earth Observation EO satellite ecological and environmental interactions that underlie on Earth system, which is a critical for developing sustainable solutions. Environmental remote sensing deals with emerging methods, technologies, and may include sensors such as synthetic aperture radar for coastal and subsidence monitoring, high-resolution multispectral data for ecosystem vulnerability, or hyperspectral data for biodiversity mapping and analysis. The focus is on environmental issues in light of climate change and human impact. Education and training is very important to impart clear concept building and believing the weather, climate, and remote sensing application required for the environmental management. In this context, Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, organizing a 3-day workshop cum training program on climate modeling and remote sensing application for environmental systems in collaboration with Indian Meteorological Society, IMS Delhi, with the aim to conduct a comprehensive training on different aspects of remote sensing applications. The idea is that all the scientists, experts, and other stakeholders across the world and nations should come together for a better understanding and solving the issues of environmental systems using the remote sensing tools and techniques. On this occasion, it is an honor and privilege for us to welcome our Honorable Founder President, Sir, Dr. Ashok Kumar Chauhan ji. Today, we are able to conduct this workshop cum training program only because of his constant support, blessing, and strength. He is a guiding force for us. Your presence, sir, is indeed a source of great motivation. My deep regards and thanks to respected Chancellor, Sir, Dr. Atul Chauhan, sir. It is his vision and leadership that has placed Amity University among the top universities in the world. Welcome, sir. I'm delighted to welcome our respected Vice Chancellor, Madam, Professor Balvinder Shukla. She's a guiding force for us, and with her support, motivation, and inspiration, we are able to successfully execute 3 days workshop cum training program. She's an excellent administrator who leads by example, who polish each one of us and lead us towards excellence. Welcome, ma'am. I extend my warm welcome and regards to our eminent chief guest, Honorable Dr. M. Ravichandran, Secretary of Ministry of Earth Sciences, New Delhi, for joining us and taking out time to share his thoughts with us in Amity University. I thank you, sir, for accepting our invitation from a busy schedule. Warm welcome to you, sir. It's my pleasure to welcome our today inaugural guest of honor, Dr. Mrityunjay Mahapatra, President IMS and Director General of Meteorology, Indian Meteorological Department, Government of India, for his inaugural address in 3 days workshop cum training program on climate modeling and remote sensing application for environmental systems. The presence of such a personality in inaugural function is a blessing. We hope that the participants are able to seek a little guidance and invite something from their thoughts. Welcome, sir, for the inaugural session of workshop cum training program. I extend my warm welcome to Dr. D.R. Patnaik, Secretary and IMS Head, NWP IMD New Delhi. We all are going to enlighten by his vast knowledge in climate modeling and mood sensing techniques. Welcome, sir. I extend my warm welcome to Dr. D.K. Soni, Scientist F and Head, EMRC, IMD, New Delhi. Welcome, Soni, sir, for the inaugural session of 3 days workshop cum training program. My warm greeting and welcome to Professor D.K. Bandyopadhyay, sir, Chief Advisor, Founder, President Office, and Chairperson, Amity Law School, and Mentor of Natural Resources and Environmental Science domain, for his continuous guidance and motivation always. I'm thankful for your kind support, suggestion, and guidance given to us as and when we require. Welcome, sir. I would like to welcome Professor Tanu Jindal, ma'am, Group Additional Pro VC Research and Development and Director of AITSM Department for her encouragement towards research. Welcome, ma'am. I would like to welcome our all speakers for today's event. Who else could have been better and more appropriate speaker in this workshop cum training program? And we are really grateful to have you all in today's session. Once again, I welcome to all present here, Honorable Chief Guest, Sir, Guest of Honor, dignitaries, participants, students, faculty colleagues, and staff members for joining us for this session. I'm sure that we all will have lots of knowledge to carry forward from this deliberation of eminent speakers from all across the world on the topics of understanding of human environment system, climate change research, responses and threshold in the Earth system, effective response to climate change, remote sensing and GIS effective tool for decision support system, and advanced research and disaster management. I'm sure that you all will feel enriched with knowledge after completion of this event. Thank you all for joining us and have a very nice day. Namaskar to all. Over to Dr. Meena Sattar Khan.
Thank you, ma'am. Thank you so much for that elaborative introduction to the theme and welcoming our August gathering. Moving ahead, ladies and gentlemen, I would now invite Professor Dr. Tanu Jindal, Group Additional Pro Vice Chancellor, R&D, Amity University, Uttar Pradesh, India, for her address to the August gathering. Ladies and gentlemen, Professor Tanu Jindal is a renowned environmentalist, educationist, and scientist with over 25 years of experience. She is currently working as Group Additional Pro Vice Chancellor, Research and Development at Amity University. She has completed several projects with various national and international funding agencies and traveled extensively across the globe, presenting over 120 papers in prestigious conferences. She has several publications to her credential. So without much delay, I would just request ma'am to please address the gathering. Very good morning, ma'am.
Good morning, ma'am. Ma'am, you're not audible. Hello, ma'am.
Any problem? Because time is passing.
Can you hear?
No, time is passing, please.
Your voice is lagging.
Ma'am, Sonu ma'am is having, I think, network issue.
So let us not delay. हॉटस्पॉट से कर दो, कुछ करो.
Yeah. Yeah, is it okay now? Is it okay now?
Okay. Just carry on
Now?
quickly. We are
Is it audible?
Yeah.
Is it audible?
Yes, ma'am.
Yes,
Yes,
it is
Manoj, you're
audible.
audible.
Yes, sir. Is it? Is
Unmute yourself. Unmute.
is it?
क्या होगा? Otherwise you go to the next speaker. Whenever her network will be right, then she will come back.
Okay, sir. Dr. Amrina, please call the next speaker.
Okay. So since Professor Jindal is facing some issue with the internet, we're moving ahead, ladies and gentlemen. I'm privileged to invite Professor D.K. Bandyopadhyay, Chief Advisor, FPO, Chairman, Law School, and Mentor, Amity Institute of Environmental Sciences, to address the gathering. Ladies and gentlemen, Dr. Dalip K. Bandyopadhyay is a professor, scientific management researcher, and an academic administrator of repute. A gold medalist in his master's degree, a PhD in computer applications, a fellow from ESSEC Business School, Paris, and an inspiring professional. Professor Bandyopadhyay has started his career from Indian Institute of Tropical Meteorology, Pune, and served there for 5 years. He also served the Indian Institute of Forest Management, Bhopal, from 2004 to 2008 as a director. He introduces different academic courses and studies in the field of environmental sciences, climate change, and environmental accounting, including ecological taxes. He was second vice chancellor of the Guru Gobind Singh Indraprasth University from 2008 to 2013. There is a lot to his credentials, ladies and gentlemen. Presently, as a mentor to Amity Institute of Environmental Sciences, he's constantly guiding us and helping us to achieve the best of our potentials. So may I now humbly request sir to say a few words to the gathering.
Thank you, Amrina. Thank you very much.
Dr.
And,
Bandyopadhyay, I have joined through, now I've joined through my phone again.
just let me complete it.
Yeah.
After me, you come. Okay.
Yeah, that's
After
great.
me, you
But
come.
somehow
Okay.
it's
Yeah.
okay.
Yeah.
Yeah.
Be online. So we are really privileged to have these 3 days workshop come training program in collaborations, or rather I would say that in partnership with IMS. So we are really thankful to Dr. Patnaik, and also we are thankful to Dr. Mrityunjoy Mohapatra. Maybe when I was in Pune, I do not know in 76, 77, whether you join IMD or not, but certainly, we can relate to each other. And our chief guest of today, Dr. A.M. Ramachandran, I welcome them on behalf of entire Amity Universe, specifically on behalf of the founder president, on behalf of our very dynamic chancellor, Dr. Utul Chauhan, and our honorable vice chancellor, Dr. Balvinder Shukla. And we are trying the different aspects of environmental sciences in the Amity Institute of Environmental Studies. And this institute has been nurtured by Dr. Tonu Jindal and has taken a greater shape now, which are being handled by Dr. Manju Raut and Dr. Renu Dhupar. And we have made our mark, in a greater way in terms of studies of the environmental sciences. Now, this is one of the feather we are like to attach to our cap in terms of having the climate modeling discussion, climate modeling training program in this institution under the sponsorship of IMS. We are really thankful to them for bestowing trust in us, and I'm assuring you that 3 days the workshop cum training program will reach to a greater success, because our whole purpose is that how do we really make the people aware what are the different facets of the climate modeling. Now, I know that there are many aspects of the climate modeling, and it starts with the general circulation models, or popularly known as GSM. And it is a very complicated mathematical equations to characterize how energy and matter interact in different parts of the ocean, atmosphere, and land. And scientists use climate models to understand complex Earth system. And that's most important thing, complex Earth systems. It has a short range forecasting, it's a mid range forecasting, it is a long range forecasting based on the different parameters or different variables are taken into consideration in the model. Those models allow them to test hypotheses and draw conclusion on past and future climate system. This can help them determine whether abnormal weather events or storms are a result of changes in climate or just part of the routine climate variations. This is most important thing. Is it that changes in climate or just part of the routine climate variations? For example, when predicting tropical cyclones, say for example, hurricanes or like that, scientists can use climate models to predict the number of tropical storms that may fall off the coast and in what region they are likely to make landfall. So that associated with that, that planning processes can be initiated, the rescue operations can be initiated, and the different type of precautionary measures can be done. And it has its greatest utility if we are able to predict the climate, in a form. So there are many types of climate models that are available: quantitative climate model and this qualitative climate model based on the synoptic charts. And in the quantitative models, take into account of the incoming energy from the sun as shortwave electromagnetic radiation, cheaply visible, and shortwave infrared as well as outgoing long-wave infrared electromagnetic energies. Any imbalances result in a change in the temperature. And if we just look at the different types of quantity models that are available before us, a simple radiant heat transfer model treats the Earth as a single point and averages outgoing energy. This can be expanded vertically, radiative convective models, and are horizontal. Finally, coupled atmosphere, ocean, sea, ice, global climate model solve the full equation for mass and energy transfer and radiant exchange. Other types of modeling can be interlinked, such as land use in Earth systems model, allowing researchers to predict the interactions between climate and ecosystems. Now, there are many types of quantitative models that we can see in the literatures. It starts with a simple radiant heat transfer model, treats the Earth as a single point and averages outgoing energy. And then there are models like, say, box models, zero-dimensional models, radioactive convective models, higher dimension model, EMIC Earth system model of intermediate complexity, and finally, climate global models or general circulation models. And there are many types of models that are available today with a very, very complex mathematical equations, and starting with using the thermodynamics laws, using the Navier-Stokes equations, using the Kelvin's diffusion equation. It's a very, very complex mathematical model that takes place. Now, this 3-day training program, essentially, we are going to bring different facets of the climate modeling, its importance, and how people should go further in developing this climate model. Because our one quote I like to make it over here all the time, our honorable founder president says, and which I quote in every of my deliberations, that today's main problem, if you ask to the president of US what is the present problem today, he will say the global warming and climate change. If you ask the Prime Minister of India, he will also say global warming, climate change. Now, if you ask me, I will also say the major problem of today is global warming or climate change. Now, how do we really understand how the changes are taking place? What are the causal effect relationship? And how do we really predict it in a long-term, mid-term, and short-term way, so that we can understand it, we can take different precautionary measures. Now, these 3 days deliberations will essentially bring out some of the facets, because we cannot run away, or we cannot survive rather. We can survive rather unless until we take into consideration how best we can control the change of temperature. Now 2030 or 1.5 to 2 degrees centigrade. Now if it is exceed that, then what is going to happen, we do not know. Again, that's a model. That's model available, that if the temperature rises beyond 2, how much ice is going to be melt, and how many countries are going to be under the sea. Now this type of modeling is a very, very interesting interesting thing to study, to research, and those researchers are doing really they are putting their heads together. And so variables are so many variables, and whatever known variables are there, we try to capture them accordingly. We use them in the model for the prediction. So I wish the coming 3 days, these deliberations are going to be very, very interesting, academically very challenging, and professionally very learning. And those participants, those who will be attending it, they will go with a lots of takeaway from these deliberations. And because there are eminent people who have come over here, and which has been actually recognized by IMS, and also some of them are recognized by our AIS, and it is going to create a different types of very, very enthusing academic deliberations. So I wish all the best. Now I must thank Renu and Manju for taking up this responsibility for conducting this training program. So once again, I thank IMD, I thank IMS, I thank the Secretary, Earth Sciences, Mr. Nayak, who used to be my good old friend, and now Ravi Chandanji, you have taken over. So I think it is going to be great deliberations. So thank you very much.
Thank you, sir.
Thank you, sir. Thank you so much. And indeed, it's always a privilege to listen to you. And you have set a perfect platform for a progressive discussion on climate modeling, weather forecast, global warming and its impact, and of course, the use of remote sensing and GIS to do the needful. Thank you so much, sir. Now I invite Dr. Professor Tanujinder to please say a few words to the August gathering.
Yeah, thank you, Dr. Ambrina. I hope I am audible now.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. Now you're audible.
Yeah, great. So I welcome Dr. D.R. Patnaik. I welcome Dr. Mrityunjay Mahapatra, Dr. M. Ravi Chandran, Dr. D.K. Bandopadhyay. Our Vice Chancellor is now busy with a very important meeting with her support and guidance and blessings of our Honorable Founder President, Dr. Ashok K. Chauhan, and dynamic leadership of our Chancellor, Dr. Atul Chauhan. I congratulate Dr. Manju Rawat Ranjan, Dr. Ambrina, Dr. Renu Duppar for organizing such much timely training program, because technology is the need of the hour, and we have such wonderful technology of remote sensing applications with us, and its use in environmental systems is the most important in current era. It is also important in many types of analysis. So I will take one by one, which our department, our domain of natural resources and environmental science is undertaking. So first and foremost, I will just quote some of the examples of the research which we are already doing. So our institute MIT Institute of Geoinformatics and Remote Sensing is having 3 projects on urban sprawl. So they are by Dr. Swagata Ghosh, and she is studying urban sprawl and its impact on climate modeling and pollution. Then there are 2 more projects on this only, and one is also on air pollution sensing. Secondly, the other research work which we are carrying out is impact of traffic source apportionment on air pollution. So for that traffic pollution also, we are using this remote sensing technology and source apportionment we are trying to carrying out. And one PhD scholar is working on it. And a very important research on glacial receding using RTK and PPK has been proposed to NCPOR, real-time analysis and PPK studies, which has been very much appreciated. And we are waiting for its approval. Once the project comes, we would be able to work on it. Next, Dr. Devra and Dr. Raju, they have submitted a project on Ministry of Earth Sciences on again meteorological data and air pollution using remote sensing technologies, that is from AUR and AUH. I myself have been personally to INCOIS, tsunami warning system. And for the tsunami warning system and coastal zone area, also remote sensing technologies have been very, very important. Recently, we also attended with NAM Center training course where for lightning hazard remote sensing technologies which are being used. And our Center for Food and Agriculture, they are also using remote sensing technologies for agriculture and climate resilience. Recently, using this remote sensing technology, we have also had a meeting with CSIR on episodic events of air pollution, for example, by parali burning. So we are trying to predict those episodic events of air pollution also using the remote sensing. With Ministry of Earth Sciences, we have proposed a very wonderful project on on knowing the rare earth metals present in West Bengal area using remote sensing technology. So remote sensing, technology has large application, and especially in environmental sciences. Recently with IMD, Dr. VK Soni would be also speaking in this particular conference. He is also co-guide in one of our students. We are also doing ozone modeling using remote sensing technology, not only in localized condition, but also pan-India, we are trying to do it. And using regression equations and also real-time water quality analysis, we have developed certain regression equation. Dr. Shivangi, who was with us, she was working on that, and we are trying to monitor using remote sensing and with the help of regression equation developed the water quality analysis also. Another application is on lysimetric studies. We are trying to develop basically an irrigation system using remote sensing data through lysimetric connection, like how much of water is required for irrigation so that we can have more crop per drop. So I've been counting, what kind of application our own domain and at MIT University, various campuses we have been working. And I'm also looking forward from further speakers to know more about applications of remote sensing in environmental systems. There are few which I could count on, and I'm very proud to say that MIT University is doing a lot in remote sensing applications. We are also pioneer in launching bachelor's and master's program in remote sensing application, MIT Institute of Remote Sensing. Dr. Veerbhadrappa is working on that. Also for disaster management, in fact, I would say that we need to work on prediction of forest fires in India. That is still, we need to work on that. And in fact, in forest fires in Amazon forest were also predicted and have been recently been predicted through remote sensing only. Now for flood management also, we need to work further, how we can use this data. Because of the climate change, large number of floods have been happening in various areas, and glacial receding, glacial melting, sea level rise. So we need to further work on that. I am looking forward to, I've gone through this list of speakers, very eminent speakers and specialists have been invited. Dr. Gupta from NIDM, Dr. D.R. Patnaik, we are very grateful for helping us in organizing this conference and sponsoring us also. So I'm looking forward with eminent speakers, and I'm also grateful for our own speaker. There are certain faculties from MIT, Dr. Madhuri and Dr. Maya is also contributing. Yes. So I wish all the best for this 3 days conference. And thank you so much for inviting me. And I am looking forward to hear the deliberations in this 3 days conference. Thank you again.
Thank you, ma'am.
Thank you, ma'am, for briefing about your research
Amrita,
work.
I forgot one thing.
Yes,
That I
sir.
must
Yes, sir.
acknowledge the efforts made by Dr. Amrina Sardar, and also the efforts made by Richa Dabenagar. I think they are, deeply involved in supporting, I would say that, or in collaborating with Dr. Renu Dhupar and Dr. Manju Rawat. I think that's a great team efforts.
Thank you
And I
so
hope
much.
this
Thank you.
team spirit
Thank you, sir.
will be there, and the 3 days are going to be very, very important days for us.
Thank you, sir. Thank you, sir. Thank
Absolutely. We all are looking forward, and please let us know any the further support is required. And congratulations. Thank you.
Thank you. Thank
Thank you,
Our
ma'am.
Vice Chancellor, ma'am, has joined us. So I would take this privilege, and I'm extremely humbled to invite ma'am, Professor Dr. Balwinder Shukla, Vice Chancellor, Amity University, Uttar Pradesh, India, who believes in hard work, determination, and achieving what is unachievable. A lady who has been a driving force, a hard taskmaster, a GIS of innovation and leadership, guide, inspiration, and source of positivity, forever aspiring us to rise high in life with wisdom and vision. Ladies and gentlemen, Professor Dr. Balwinder Shukla is a PhD from Queen's University, United Kingdom. She has over 3 decades of rich scholarly experience in industry and academia. Dr. Shukla is a professor of entrepreneurship, leadership, and IT, and the Vice Chancellor of Amity University, Uttar Pradesh. She has been the sky to her team members who looks up to her, spearheading and instrumental in the exponential growth of Amity Group engaged in higher education. Ma'am, who has been a satellite of enthusiasm and motivation, a guiding star, and an excellent administrator who leads by example. She is an epitome of love, passion, and compassion. She is a goldsmith who polishes each one of us and led us towards excellence. With all due respect, may I now request ma'am to say a few words and blessings.
Thank you very much, Dr. Amrina. A very esteemed, distinguished guest of the day, Dr. D.R. Patnaik, Secretary, IMS and Head NWP, IMD, New Delhi. Our guest of honor, Dr. Mrityunjay Mahapatra, President IMS and Director General of Indian Meteorological Department, and all my colleagues, Professor Bandyopadhyay, Dr. Tanu Jindal, HOIs, faculty members, all the distinguished speakers from across the country and participants. First of all, I, on behalf of our Honorable Founder President, Honorable Chancellor, and on my personal behalf, I extend very warm welcome to our distinguished guest of honor, Dr. Mahapatra, as well as Dr. Patnaik. On the 3 days workshop cum training program on the theme climate modeling and remote sensing applications. We all know that how important is the environment and climate change, and studying its impact on the various aspects of the lives, not only human lives, but the any kind of lives, whether it's the plant life or the animal life, and how it's impacting. And I'm very happy and delighted that the Amity Institute of Environment Sciences have taken initiative in collaboration with the IMD to organize this workshop. And I'm sure this 3 days workshop is going to give a lot of learning, and whether it's understanding the human environment systems, climate change, research responses and threshold in the Earth system, or whether it's effective responses to climate change, vulnerability and adoption through the climate change modeling, or with the remote sensing and GIS as effective tools for decision support systems, advanced research and disaster management, and integrated climate observing systems, and remote sensing application for the environmental systems. Even the United Nations Sustainable Development Goals has focused immensely on the environment and climate, and how the not only the industry but all stratas of the society, and especially the education institutions, can contribute to the for the sustainability. And organizing this workshop will surely educate everyone that what can be the new tools and techniques for measuring the climate, and how the future initiative can be taken for having the the sustainable environment initiative can be taken. And so therefore this workshop is going to give one side developing an understanding in the field of climate change modeling and the remote sensing applications, because it has a lot of employability opportunities for the youngsters. And the number of opportunities are going to increase in future, because the environment is going to be one of the very important aspects for all businesses, for all organizations. And the experts in future in this area will play a very important role. And also it will help the assess how to use the research findings to address the problems of environmental systems with available tools and technologies. And so all those research scholars, or the researchers, or the scientists, or faculty who work in this field, it will be very useful for them to learn to use the various tools, and also to identify the opportunity and research strategies for mitigating and managing climate change and extreme weather events. And and also that it will help in gain actionable insight into the mapping and predictions of weather parameters with the use of remote sensing and GIS, and mapping and monitoring the impact of human activities on environment, and establish linkage with the climate change through the modeling and the remote sensing. And also that participant will be able to explore the ways to design the and cause impactful research that would lead to the sustainable solution to environmental system using climate change models, remote sensing, and the GIS. And I'm sure that the team of AIS and the natural resources um, department, which they have been doing the lot of research in this area, will find the opportunities to work with the work jointly with the various organizations like the Indian Meteorological Society and the other various organizations, how to collaborate, how to work together, how to develop the synergy, because the environment and the climate change is a common factor and common interest area for all stakeholders. And therefore, the partnership or collaboration with the various organizations is very important, how to build that research, and also to understand what are the various problems, and how MIT researchers and scientists can work on those thrust areas in collaboration and find the solutions in the form of maybe the technologies, maybe tools, or maybe the new approaches, and contribute to the not only for the to the society, but also to contribute to make this environment a better environment for a future. And that will be the contribution to for the future generations, what as a education institutions and what as a research organizations we can do, because a lot of deterioration of environment has happened because of the human beings own personal interest, Those may be the commercial interests, maybe the other interests, the way the deforestations have happened, the way the various carbon emissions because of that, or any other areas. And there was a time when we used to say that clear water of the rivers, and you were able to see the base of the river, and today you are not even able to see the surface is all black, dirty, and completely polluted, which has a direct bearing on the ecosystem, the all the aquatic the lives have been impacted very badly, and also that water is also impacting the health of the human being. And we have seen that so many species have vanished because of the pollution. It's especially the water pollution. It has also impacted the um, that the lives in a big way. I'm sure that this workshop is going to bring lot of not only the learning, and also will bring a lot of opportunities for the researchers and scientists to work in the trust areas to make this planet more sustainable, by addressing the climate change issues through the climate modeling and the remote sensing applications for the environment systems. And this has a lot of scope that to work not only with the Indian organization, but also the international organization, because the climate or environment does not have the boundaries, and that these are the universal challenges, and therefore working in collaboration with the global organization is extremely important. Once again, I would like to thank Dr. Mahapatra for sparing his time and being with us. And also I would like to thank Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, for sparing his time and being with us. And I'm sure your presence will not only motivate the student researchers, but it will also provide the opportunity in future to work together to make this world a more sustainable world for the humanity and all the lives. Thank you very much.
Thank you so much, ma'am, for your
Thank you,
blessings
ma'am.
and stirring words. And indeed, together we can and we will try to change the world. Thank you so much. Ladies and gentlemen, I'm feeling so privileged now to invite Dr. D.R. Patnaik, Secretary, IMS and Head, Numerical Weather Prediction, IMD, New Delhi. Ladies and gentlemen, Dr. D.R. Patnaik obtained his master's degree in physics from Sambalpur University, Odisha in 1991 and PhD from Pune University in 2001. He joined IMD in 1998. Dr. Patnaik is presently working as Head of Numerical Weather Prediction Division of IMD, and his area of interest are monsoon and climate variability, climate prediction, extreme weathers, extended range prediction. He has published more than 75 scientific research papers in national and international journals. Ladies and gentlemen, Dr. Patnaik's persistent scientific contributions brought him much recognition and award, like Certificate of Merit for Outstanding Contribution in the Field of Atmospheric Sciences and Technology by the Ministry of Earth Sciences, Government of India in 2011. Also, Young Scientist Award for the Best Research Paper published in Tropical Meteorology for the year 2014 by Indian Meteorological Society. So it's a privilege to have you here. And as a tradition of our Amity University and keep this bonding going, we wish to felicitate you with Tulsi sapling. I request Dr. Naresh. Dr. Renu Rupert, the program convener, is presenting a virtual Tulsi sapling to Dr. J.R. Patnaik. So please accept our gratitude.
Thank you. Thank you very much, ma'am. Yeah, so very good morning to all the panelists here and our distinguished Vice Chancellor, Dr. Balvinder Suklaji, Professor D.K. Bandopadhyay, member of Amity Institute of Environmental Sciences. Secretary, Ministry of Arts Science, Dr. M. Ravichandran ji. Dr. M. Mahapatra ji, President IMS and the DGM IMD. Also, the Dr. Ashok K. Chauhan, Dr. Renu Dupe, who is the coordinating this workshop, and Dr. Manju Rawat, that will be joint coordinator, all our viewer and distinguished scientists, those who will be delivering this stuff, and also all participants. So it is a very great privilege for me to address on this occasion. This is a very important workshop, and it is being conducted by Amity University along with IMS on climate modeling, remote sensing applications for environmental systems. So this is two actually important parts you are covering. The climate modeling, it is a complex system. Climate is a complex system. And so how, when we see the evolution of the climate modeling, it is a long history of more than 100 years. Slowly it has progressed. And now it has come to a stage where we can rely on the forecasting by modeling group. But at the same time, earlier occasions, the challenges were not that much. Okay, people requirement was very limited. But now as the progress, science has progressed, modeling has progressed, the challenges are also increased. Now people need very accurate forecast, location specific forecast, actual amount of rainfall, timing of rainfall, at what location, what time, all these things are there. But the climate change, because of the climate change, there is already an increasing trend of heavy extreme weathers. So that has also added to the challenges of all our forecasting and service providing agency like IMD. But yes, we are trying hard, and we are to meet the public demand. And as an Indian Meteorological Society, if we look at the broad objective of IMS, the advancement, it is the advancement of meteorological science in all their aspects, dissemination of knowledge of meteorological sciences among the scientific community and general public, and application of science of meteorology in various sectors for the benefit of society like agriculture, water resource, tourism, disaster management, health, and many such. So this is a broad objective. These are the broad objective of IMS. And to fulfill this objective, IMS is regularly doing this workshop, training workshop, transferring on knowledge. So when the madam actually discussed, it was very, we thought, let us have a very good idea. And I discussed with our president, Mahapatra sir, and also we discussed in our meeting. So yes, if our university is willing to do this very important workshop, then we will definitely support. And because that is the objective, that is the broad objective of our thing, to fulfill this thing. And this, if I look at the program, it is a very comprehensive program, scientific program. Very distinguished scientists will be talking, and more than, now I can see the number is more than 227 people. So it is a good number actually. In fact, we can say online participating. So that is a very good number, and they will be benefited. And Amity University is also growing. And we have attended last time actually, as an expert, we visited this thing for evaluation of some project long back. And so this 3 days workshop, particularly on the climate modeling and the remote sensing application, because remote sensing application is also a part of how the disaster management, because now it is integrated, means even the forecasting alone by the best model is not sufficient. How you will customize the forecast product, and how you will utilize this remote sensing, so that the disaster managers can be benefited, and they will be able to give this warning. So this 3-day workshop on particularly all these topics will be very beneficial for the students, and also people will be attracted towards this field of meteorology. And many students may also enroll for PhD. That is also objective. So that is good idea. So that you should encourage people, and you should attract people to join and do science of meteorology and carry out the PhD. And I wish all the best, all the successful, and I wish this will be a very successful one. And once again, I thank all our delegates and participants from Amity University and all experts and viewers. Thank you very much, sir. Namaskar.
Thank you, sir.
Thank you so
Thank you, sir.
much,
Thank you
sir,
so much, sir.
for your
Thank you
wonderful
so much, sir.
words. And of course, sharing the challenges with climate and weather prediction and forecasting, and also to share the aim and the objective of Intermeteorological Society. And of course, we are looking forward to have collaboration with you so that we can work together and also encourage students to pick up meteorology as their core field. Thank you so much, Patnaik sir.
Thank you.
Ladies and
Patnaik ji,
gentlemen, I am feeling.
Dr.
Rina,
Patnaik,
Dr.
Yes, sir.
Dr. Patnaik,
Yes, sir.
now we have taken a single step of our journey. We have to walk a mile.
Yes, sir. Yes, sir. Step by step,
we have to walk, because I do not know whether I met you or not. I do not know. आप मिश्रा जी को जानते होंगे. मिश्रा जी जो न्यूमेरिकल वेदर प्रेडिक्शन में काम कर रहा था, वो हमारा कैपिटल मेट्रोलॉजी था. सब्सिक्वेंटली आके दिल्ली में आ गया था. आईआईटी दिल्ली में था. वहां जाके वेदर प्रेडिक्शन का एक सेंटर खोला था. एसके मिश्रा.
Yeah, I know.
वो मेरा बॉस था.
Oh, yeah. He basically dynamic meteorology. He's expert in dynamic
dynamic meteorology, theoretical studies.
Yeah, I know him. I also did PhD in the IITM. So
अच्छा.
Before joining IMD, so I know.
मैं 79 छोड़ दिया था, तो उसके बाद वो मॉनसून एक्सपेडिशन में, मैं मोनेक्स एक्सपेडिशन में गया था, जहाज के ऊपर था. 1.5 महीने बिताया था.
Madam, you can encourage people to become the live member of IMS on this occasion.
Absolutely, sir.
Sure, sir.
Absolutely. We'll do that, sir. We'll do that.
बिल्कुल.
Thank you, sir.
And we have to collaborate a lot, because this is going to be the future.
Yes, sir.
It is going to be the future, because climate change is going to be the future, and modeling plays a very important role.
Yes, sir. Okay.
ठीक है, sir.
Thank you
very much. Thank you very much.
Thank you, Patnaik sir. Thank you, Patnaik sir.
Moving ahead, ladies and gentlemen, I'm so privileged and honored to invite our guest of honor, Dr. Mrityunjay Mahapatra, President, IMS and Director General of Meteorology, Indian Meteorological Department, Government of India. Ladies and gentlemen, Dr. Mrityunjay Mahapatra is the Director General of Meteorology, IMD India, and Permanent Representative of India with World Meteorological Organization and member of Executive Council WMO. With a PhD in physics and 28 years of experience in meteorology, he has made significant contributions in improvement of early warning services of IMD. He brought laurels to the country from international agencies for effective cyclone warning. He is popularly known as the Cyclone Man of India. He is the author of more than 105 research papers in peer-reviewed national international journals. He edited 18 books and seven journals. He received award recognitions from different agencies, including Honorary DSc from FM University and Kalinga Institute of Technology, Fellow Indian Meteorological Society, Certificate of Merit for Young Scientists by Ministry of Earth Sciences, 25th Biennial Mosam Award, and appreciations from press, electronic media, and social organizations. Currently, he is President, Indian Meteorological Society, Chairman, Regional Sub-Project Management Team of Severe Weather Forecast Program for South Asia, and was Chairman of WMA SCAP Panel on Tropical Cyclones for 2017 and 18. Task Team for finalization of meteorological payloads of INSET-4 satellites to be launched in 2025. Committee for Revision of NTMA Guidelines for Cyclone Management, Technical Evolution Committee for Consultancy on National Cyclone Risk Mitigation Project. Ladies and gentlemen, it's again our great privilege to hear from Sir and learn from his wisdom. But before I request Sir to address the gathering, I would request our team to please felicitate Sir with Tulsi sapling, a bond of friendship and lifelong association. Our mentor, Professor D.K. Bandyopadhyay, is felicitating our guest of honor. So please accept our felicitation. Ladies and gentlemen, Dr. Mahapatra.
Good morning, sir.
Good morning, sir.
Good morning, namaskar.
Good morning,
Namaskar, sir.
Namaskar, sir, and good morning. Namaskar.
I extend my heartiest congratulations to Amity University, all the distinguished guests and panelists, the participants, delegates, and ladies and gentlemen. Respected Dr. M. Ravichandran, Secretary, Minister of Arts Sciences. Dr. Ashok Chauhan, Founder President of this MIT Foundation. Dr. Atul Chauhan. Dr. Patnaik, Secretary, Indian Meteorological Society. Professor Malvinder Shukla, Madam, Vice Chancellor, MIT University, Uttar Pradesh. Dr. D.K. Bandyopadhyay Sahab, Mentor, MIT Institute of Environmental Sciences, MIT University, Uttar Pradesh. Professor Tonu Jindal, Dr. Renu Dhupar, and distinguished guests, delegates, students, and faculty members. I congratulate all of you for organizing this timely 3-day training workshop on climate modeling and remote sensing applications for environmental systems. I thank both IMS and MIT University for taking this endeavor. As all of us know, that information on weather and climate is everybody's requirement. As and when we get up from the bed, knowingly or unknowingly, we look at the sky to find out how is the weather today. So by that way, every person in the society becomes a forecaster, believing the proverb that morning shows the day. But really, if you just look at the type of weather which is occurring, and especially the variation of weather in view of the climate change in the present days, we'll find that the proverb which we learned in the childhood, the morning shows the day, is not applicable with respect to the weather and climate. So to address this challenge, the society has taken up various initiatives from the very beginning with a scientific approach. We can find out about the attempts made by the society in our epics, even in Gita or Mahabharata or Ramayana or Vedas. You can find out the mention of the measurement of rainfall and its importance, even in Vedas. And also in medieval India, you will find out the need mentioned by Chanakya. But however, in the present day world, when people thought of making it an objective approach for monitoring and forecasting weather and climate, the first initiative came off in the form of the Meteorologica, the book published by a Greek philosopher, Aristotle. But if you compare the society in India and the world, we are not behind at any part of the time. There has been an attempt, as I mentioned, a few examples in the recent history and also in the past. And also in the instrumental period, which started mostly around the beginning of 1800s, India has also ventured to adopt all the new tools and technologies for monitoring to begin with, and afterwards for analysis, understanding, and forecasting. With the advent of the thermometer in 1800s, the first instrumental observation started in the world. It was continuously followed up, and the number of observations started, and people could understand that if we really want to predict weather at any day, at any part of the world, we need to understand the weather occurring over the entire world. So this basic concept or the basic idea which struck to the mind of the scientists at that time, they decided a branch of meteorology that is called as synoptic meteorology. The word synoptic means the simultaneous, and hence the concept was that if we can have a simultaneous observations of weather and weather parameters across the globe, then we can have a clear picture of what is happening in the world today. Because weather and climate has no boundary. And someone told, if there is a flapping of the butterfly, a butterfly is flapping the wings in Africa, it can cause weather in India or in USA. So this concept came up with Lawrence afterwards, and that began the story of providing the numerical modeling of the weather and its forecasting. So however, worldwide, the synoptic meteorology commenced long back, and accordingly, based on observations of weather and climate, people started to provide what is happening today and what can happen, say, tomorrow or today. It has the limited accuracy because it is just an extrapolation of the understanding what has happened during past, say, 24 hours and what is going to happen, say, for next 24 hours. And later on, people came up with the tools like based on the historical observations. When we have got the historical observations, for example, at least 30 years, we can develop a climate. And climate understands the average occurrence of the phenomena. People try to provide the forecast based on the climatological behavior of the systems, like the thunderstorms or cyclones or heat waves, cold waves, or floods, etc. But again, the climatology has its own limitations because it is just based on the past history. And climatology will have a limited memory. It cannot provide you the long-range forecast. The statistics cannot lead to a longer lead period forecast. It has got limited memory because it is based on the past data. Then people thought of combining the synoptic meteorology and then the climatology. The concept came as the synoptic climatology. And that came on, and that also used for some time. And finally, people thought that, no, we should go for some kind of rigorous statistics like regressions or regression modeling. And that also supported, but people again found that it has the limitations. So finally, as I was telling you, the concept of dynamic meteorology came up, and people thought that if you really want to address the problems of weather and climate, you have to address the dynamics involved in the atmosphere. So initially, the model came off gradually. As the computing power improved gradually, the computation improved, and accordingly, the models also improved. People tried to understand the phenomena occurring in the atmosphere, and they could find that 6 to 7 equations would be enough to address the various atmospheric processes. And later on, people found that atmosphere is not alone. Atmosphere is also getting affected, and atmosphere is also affecting the other environments like land, ocean. And then gradually, the modeling system also improved to take care of all the components of Earth system science, like atmosphere, ocean, and the Earth, and their interactions. So in all these endeavors, the modern day numerical weather prediction model started in 1930s. And it became really the more useful from 1950s onwards. People tried to develop some kind of model. And finally, in the 90s, the world saw a number of numerical weather prediction models. In India, also, we adopted one model in 1990s from USA. That was the beginning of the modeling system in India. Of course, prior to that, we went on dynamic theory and practical applications. We tried the various types of activities. But truly speaking, the adoption of the numerical model from USA in 1990 began the era of providing the numerical weather prediction model-based forecast to the people. But as we went on from 1990s, we found that we don't have sufficient computing power, and we are not addressing the local data because that model was adapted from USA. And then people tried to understand the models and adapt it in the local scenario by ingesting the various types of data. At the same time, further people understood that the space what we thought of, just like Einstein told, it is a 4-dimensional. In atmosphere also, or ocean, we have to consider the 4-dimensional behavior of the dynamism. So therefore, there was an attempt to integrate the data not only in space scales, but also in the time scales. So there is a continuous ingestion of the data from all the observing platforms at present, utilizing satellite, radar, and man-made observational systems from the ground. And also many remotely sensed observations which are not so much systematic. You will be happy to know that at present, when you think of modeling, Minister of Earth Sciences has got about 7 numerical observation models being run on daily basis, twice at least. And in this modeling system, if you consider the amount of data which is going into the models, that is about more than 200 GB data is going for one single run of the models. And if I compare the total amount of remotely sensed data which are collected by the various satellite system, both geostationary satellite and power-orbiting satellites, only 5% of the remotely sensed data are being utilized in the models. That means 95% of the models, 95% of the remotely sensed data are not being utilized at present by the models. Hence, there is a scope to improve further the application of remotely sensed data in modeling systems. Why is it so? It is mainly because we don't have sufficient computing power to utilize all this data, number one. Number two is that, as the term goes in, it is remotely sensed data. It is not the ground truth. And therefore, this data needs validation, data needs improvement so that it can be used in the modeling system. So, however, the Minister of Earth Science and many academic and institutes are working together in the country and outside to understand all these aspects and improve the numerical modeling systems. There was an institutional mechanism which came off with the establishment of Minister of Earth Sciences, and as Bandapadhyaya was telling, that Institute of Technology came off initially from India Meteorology Department, and finally we came up with Indian Institute of Tropical Meteorology, which is a modeling hand for India Meteorological Department. Similarly, we came up with National Center for Medium Range Weather Forecasting in 80s, and that is also an important hand for numerical modeling systems. So while doing all these things, people thought that we should go a little beyond than predicting the weather. The weather prediction is basically now limited up to 5 to 7 days. But beyond that, there was a need for planning, preparedness, prevention against various types of multi-hazards and also various socioeconomic applications. And as all of us know, that monsoon is the bread and butter of India, and there was a need to provide longer range forecast for monsoon. So therefore, people thought of developing the ways and means, and accordingly, India Meteorology Department introduced complete seamless prediction system, starting with the forecast for a few hours, which is called as nowcasting, to short-range, medium-range forecast based on these numerical models, then extended range prediction system starting from 1 week to 4 weeks, based on the combination of weather models and climate models, and then the seasonal prediction system based on the dynamical climate forecast system. So you'll be happy to know that in the country now, we have got all sorts of models starting with a few hours to a season of 4 months or 3 months. At the same time, the accuracy of all these models have improved over the years, but still there are certain gap areas because India is such a country which is surrounded by the Himalayas to the north, Bay of Bengal and Arabian Sea to the west, east and west, and Indian Ocean to the south. At the same time, we have got the Eastern Ghats, Western Ghats, desert regions in the West, and also we have got many other physical variations. And all these are data sparse regions. That puts a great challenge because in the field of meteorology, we say it is an initial value problem. That means if you can define the initial status, then you can have the better forecast. So define the initial status, you need more accurate and dense observation across the region. So these physiographical limitations in the country are being overcome with the utilization of remotely sensed data. So therefore, your topic, which has been taken up as climate modeling and remote sensing applications, is very appropriate, as it will try to address the importance of the remotely sensed data and its better and better applications in numerical modeling system. The climate modeling becomes more important in the sense that there has been the climate change. Now it is an accepted fact that the climate is changing. And when you go for climate change assessment, there are three aspects. One is the detection. You have to detect whether the climate is changing. The climate is changing does not mean that it is changing everywhere or it is changing everything. Say, for example, if you look at the climate change phenomena, the amount of rainfall which we are getting in the country during the season as a whole, it has not changed. Total amount of rainfall remains same over the years for the monsoon season. But if you consider the number of days with heavy rainfall, number of days with light rainfall, what do you find? The number of days of heavy rainfall is increasing, whereas the number of days of light rainfall is decreasing. So therefore, this is just an example. So it will have various repercussions. For example, it will lead to urban flooding, it will lead to cloudburst type events more, it will have riverine flooding sometimes. So while the total amount of rainfall remains same. Again, at the same time, variability of rainfall is also increased. That means you can expect more droughts and floods, even if the total rainfall remains same. Similarly, if you consider other phenomena, like say, for example, tropical cyclones, the total number of cyclones occurring in the globe is not increasing. Similarly, if you consider total number of cyclones in the Bay of Bengal, Arabian Sea, it is not increasing. But if you consider the intense cyclones, say, for example, extremely severe cyclones with wind speed of more than 160 kilometers per hour, that type of cyclones is most increasing in North Atlantic, followed by West Pacific, and also in Arabian Sea. The Bay of Bengal does not show any increase. It remains almost same. So like that, there are various aspects of the impact of the climate change. So that needs detection. How you detect it? We should follow a standard mechanism, and there is a huge research in this field. And I hope MIT University and all scientists present here can take up this issue to really find out what is happening based on the data. If you go a little longer, then you have to consider the proxy data, the data from the oceans, data from the Himalayas, data from the coast, etc. So all these will have the various types of repercussions and we have to define. The second one is if you detect that yes, it is occurring, then you should attribute it. Is it because of the climate change, or is it because of the global warming? Because as scientists, as academicians, you should speak in such a way that is authentic, that is believable, that is proved. We cannot say like a layman. So I request this gathering, so you can also take up this research work to find out the attribution, whether this change is because of the increase in carbon dioxide, or because of the increase in population, or because of increase in urbanization, industrialization, or it is a natural variability. It may be the part of natural variability because of the astronomical changes. And third one is the projection. So there are various models, and you will be happy to know that India for the first time has also come up with the climate modeling system. In Indian Institute of Tropical Meteorology, we have got a Center for Climate Change Research, which is taking off all the study, and also they have developed the data set. So what I will suggest again here, the community can utilize the data available and run the regional climate models to better understand the climate change and its impact. Now, this is the major area for the scientific community and the Center for Earth Sciences in MIT University if you are interested to work on the climate modeling and application of remotely sensed data. Now, apart from that, there are also other aspects like adaptations and mitigations. And that follows once we have proved that, yes, it is the climate change and it is the past actual fact and detection, and this is the attribution, and this is the projection. And projection also, it is not like the simple modeling. The projection is just based on the ensembling of various climate models and its output as expected by the IPCC for various scenarios of global forcing, relative forcing. So you may go for RCP 4 or RCP 8.5, whatever it is. And accordingly, people go for projecting what will its impact on various severe weather events and other parameters, etc. So there is enough scope. I think this 3-day workshop will be very helpful and educative for the students and researchers, especially the young researchers who can work with the senior scientists, and they're in a breeze for the free flow of the thoughts from old to new and new to old. At the same time, if you ask, what is the role of IMD? What support IMD can provide? I just want to say that IMD is a storehouse of knowledge. IMD is a storehouse of data. People now thought of the big data. Now we think of about the data available with IMD. In 1881, first India delivered the report was published by IMD. 1891 onwards, we have got all types of data in digital format. Most of the data are now available in the website. So you can utilize all the data. You can collaborate with IMD. You can get all the information, and you can enhance the research for the benefit of the society. The next one is the human resource. IMD is a regional center, you can say, in the South Asia, Southeast Asia, and Middle East. We lead as a regional leader here and provide support to them. So within the country also, the human resource which is available within IMD can be utilized through collaboration. There can be collaborative R&D with the scientists in MIT University and scientists in IMD. Not only for formal PhD, but also for all the projects and various types of activities which can be taken up to address the requirements in the present day. There is no sector in the society now which is not influenced by weather and climate. As the forecast accuracy is increasing, as the socioeconomic condition of the society is improving, there is ever increasing demand for the information about weather and climate. And I hope this gathering will take scope of this demand and fulfill the demand supply chain. I wish all of you all the best for success of this 3-day workshop. Thank you very much.
Thank you, sir.
Thank you so much, sir.
Thank you, sir.
Thank you.
Thank
So
you,
much, sir.
Dr.
And
Thank you, Dr. Mohapatra. Thank you very much.
thank you,
It's
sir.
a really very interesting, facet that you have brought in. Very interesting. And those participants, those who are attending over there, students and others, and they will get a very good feel that how interesting the subject is, so that they will also try to take some initiative in terms of propagating it or
Absolutely.
practicing it, either of these two. So thank you, Dr. Mohapatra. Thank you very much.
Thank you so much, sir, and very well
Thank you,
said
sir.
by Professor Bandyopadhyay, sir. How easily and with so simplicity you have explained that, how we can forecast the weather every day, every morning, and how we all can be the part of this weather prediction model. The connection was so beautifully put forward with the flapping of butterfly wings and its impact, miles away. I think that sensitivity and simplicity is required to understand our planet. And if we, all of us get that, simplicity and sensitivity, I think we could be able to help our planet and, in many ways. And of course, the capacity building is a key, because this whole idea is to make our younger generation and researchers to take interest in this wonderful field of climatology and meteorology, and take this legacy forward with all the authenticity, as you have mentioned, and with the passion. Thank you so much, sir, for gracing the occasion. Moving ahead, ladies and gentlemen, I'm very humbled and privileged to invite our chief guest for today's event, Dr. M. Ravichandran, Secretary, Ministry of Earth Sciences, New Delhi, India. Ladies and gentlemen, Dr. M. Ravichandran has assumed charge as Secretary, Ministry of Earth Sciences from 11th October 2021. He obtained his PhD degree in physics from University of Pune. He was director at NCPOR Goa 2016 to 2021. He worked as a scientist in Indian Institute of Tropical Meteorology, Pune from 1988 to 1997. He worked as scientist at National Institute of Ocean Technology, Chennai from 1997 to 2001, and also worked at the Indian National Center for Ocean Information Services, Hyderabad, before joining NCPOR. Ladies and gentlemen, currently Sir is Secretary to Ministry of Earth Sciences, Government of India, Vice President to Scientific Committee on Antarctic Research of International Science Council, Capacity Building, Council Member for International Arctic Science Committee, Alternate Delegate India Scientific Committee on Antarctic Research, Indian Republic Council of Managers of National Antarctic Programs, and Alternate Delegate India Antarctic Treaty System. Ladies and gentlemen, Sir is also an editor for Pre and Applied Geophysics, Atmospheric and Ocean Science from 2015 to present. Sir, it's a privilege and honor to share the same platform with you. Truly, I'm overwhelmed. And as a traditional of our Amity University, we want to nourish this collaboration forever. So we wish to felicitate you with Tulsi Sapling. We request you to please accept our felicitation. Our Vice Chancellor, Dr. Professor Shukla, is presenting the virtual sapling to our Chief Guest, Ravi Chandran sir. Now I request Sir to please address the August gathering.
Thank you.
Good afternoon, sir. Good afternoon.
Good
And
afternoon,
welcome
sir.
to
Namaskar,
our 3 days workshop cum training program. Namaskar, sir.
Thank you. Thank you all. And respected Dr. Ashok Chauhan, Founder President, Ritten Beloud Education Foundation, Dr. Mahapatra, Director General IMD and President of IMS, Dr. Balwinder Shukla, Vice Chancellor of Amity University, Professor Pandavijay, Mentor, Amity Institute of Environmental Sciences, Amity University, Dr. Patnaik, Secretary, IMS, Professor Tanu Jindal, Additional Pro Vice Chancellor, Amity University, various speakers, participants of this workshop, invitees, students, and all. A very good morning to all of you. First of all, I wish you all a happy and prosperous New Year 2022. Thank you, Amity University and Indian Meteorological Society for jointly organizing this workshop and inviting me for this same. Climate modeling and remote sensing applications for environmental system is an important topic of today to study and understand the global warming scenario under the various global warming scenario. The numerical modeling, basically it started very early. Of course, it mainly started with the mapping heat and mass only to monitor for measuring the temperature and the humidity and the wind. So these are the three prime variables change the atmospheric dynamics, the physical systems. So with that, they try to map where the heat and mass changes from one time to another. Then later on, they found that there is an influence in the ocean. So they try to monitor the temperature, salinity, and currents, and they try to map the heat and mass in the ocean. So then they couple what is the interaction between the ocean and the atmosphere. So they try to couple the ocean and atmosphere. So if you want to have a weather system or you want to forecast a few days or maybe up to a week, you have to depend on atmospheric variables. Whereas if you want to go beyond a week or 2 weeks or beyond scale, you have to depend on the ocean. The energy or the memory is stored in the ocean. Then by incorporating, there is an atmospheric and ocean model evolved with various complex equations. Then they started coupling the sea ice because the polar regions are the first place to understand or maybe the first place to respond to climate change. So how the sea ice and ice sheets are changing. So, and what is its influence? So they try to couple ocean atmospheric model with the sea ice. So then it has formed atmosphere, ocean, sea ice coupled model.
Then later on, that is not enough. We need to couple the land as well, the response of the land. So it is evolved with the land, ocean, atmosphere, cryospheric model. Then finally, it is started again with it is the physical system of atmosphere, ocean, and land. Cryosphere model is not sufficient. There is a major influence on the atmospheric chemistry, both in the ocean. Maybe the chemical traces may play a major role both in the atmosphere and the oceans. So they incorporated the atmospheric model in the atmospheric model and the biogeochemistry in the ocean model. So they try to couple the chemistry component in the coupled model. So the climate model evolved in such a way, atmosphere, ocean, with the physical and chemical and biological, and also the cryospheric component has been all the way to where that they coupled. So it is a complex model, complex things. So only our aim is to how to reduce the uncertainty. So that's a major goal in our endeavor. So similarly, when you come, of course, the how good the model. So for that, the observation helps. So okay, this is the way it is. Observation is showing, but what is the model simulation? Compare it and try to project it in the model. So in that way, the remote sensing has come handy. Especially in the late 90s, it has provided various variables of atmospheric and ocean to parameters in various depths as well as the atmosphere levels. So with the observation and climate models, so many people have started various climate models, and with that models, IPCC able to come out with the valuable advices to various stakeholders. So as IPCC pointed out, recent report says that it is very clear message, unlike earlier IPCC, this IPCC has provided a very clear message that the recent changes in the climate are widespread, rapid, and intensifying, and unprecedented in 1,000 years. So that's a very clear message that's been given in broad message. They also report that the report also pointed out that this change is humans are responsible for global warming. Some climate systems are irreversible, at least for centuries. It cannot be reversible. And although time is running out, it is important and it is not too late to avoid the worst impacts of climate breakdown. Of course, due to these changes, we could foresee some of the impacts now as well as in the future we may expect, such as extreme heat, more frequent and intense are happening, droughts are increasing in some regions, heavy and extreme precipitations are increasing, more frequent and intense, and more frequent wildfire is happening in many places. And also in the ocean, it is continues to warm, also acidifying, and also it loses oxygen for the bio things. So in order to understand various climate earth system, it is imperative to use observation both in situ and remote sensing to mainly to understand them and model them, and so that can be predicted well. So as I mentioned, though most of the models are simulating the current system reasonably well for the larger domain or the bigger picture, as IPCC pointed out, but still we need to improve the models for better simulation and prediction. There are a lot more work to be done, especially for the local and the smaller regions, and also mainly the polar regions. For example, none of the models could simulate, especially climate models, to simulate the Arctic and Antarctic sea ice change perfectly, because the observation shows a dramatic decrease in sea ice, whereas the model, most of the model able to simulate less decrease. So the projections is grossly underestimated. And because the polar regions are important for regulating Earth system, and both sea ice and ice sheet are melting rapidly in the recent decades, it is imperative for us to simulate the sea ice as well as the ice sheet dynamics in the polar region and document various teleconnections between the poles and the tropics and its impact in the human especially the society. Of course, the long-term remote sensing satellite data are important to understand one of the important climate change consequences are the sea level rise. Of course, the sea level rise is due to both steric as well as non-steric components such as ice and glacier melt. The total sea level can be monitored by altimeter as a remote sensing satellite, whereas the thermospheric component of the sea level can be monitored by the institute such as Argo and other parameters. So whereas the gray satellites can provide the helosteric component. So if you make it as GRACE observation, institute observation, Argo, together it will give the steric component, and whereas altimeter total sea level rise be able to give. So by using various observations, now it is possible for us to understand what is the change is happening, especially in the sea level in the long-term change. Of course, the Indian Ocean is warming much faster than other oceans. The sea level is increasing at a rate about 3.3 mm per year globally, but in the Indian Ocean, it is much more. Of course, the remote sensing data, especially altimeter, provides the Indian Ocean sea level rise is more than global mean, and it is mainly due to the thermospheric rather than other ocean like non-thermospheric component. And it is having a lot of a decadal variability. So hence it is imperative for us to discuss and understand various processes in the climate earth system. I mean, we need to understand better. Once we understand, we model them, and so that we can better prepare to forecast the future scenario for various stakeholders. Hence, this workshop and training is in need of the hour. I understand in the coming 3 days of this workshop and training, various topics are planned to cover and discuss, especially climate change impacts and how the remote sensing and GIS tools are utilized to understand our environmental changes and how we can respond to it. So also we plan to build, I think at the end of the workshop, the new capacity will be developed in India to develop the understanding as well as future climate researchers. I am sure at the end of the workshop, there will be a recommendation for policymakers, scientists, and various stakeholders. I wish the workshop be grand success, and I'm sure at the end of the workshop, participants will take on some extra knowledge at the end of the workshop. Thank you, one and all. Thank you very much.
Thank you so much, sir. Thank you very much for elaborating on atmospheric dynamics and how these climatic parameters are related, correlated, and mapped for understanding the various weather patterns. The major goal that you have mentioned, of course, that how we can use this knowledge to reduce the uncertainty of climate and the climatic phenomena. Definitely, these 3 days training would, achieve in the coming 3 days that how we can work, by the use of these data and the application of remote sensing and GIS, as you have mentioned. And we all as environmentalists completely agree that, we as Homo sapiens and responsible for the deterioration of our planet, but with scientists and researchers of your stature, we definitely looking forward to learn, rectify ourselves, and help our planet to sustain for a longer period of time. And as you have mentioned about the outcomes, so we'll definitely have documented it, jotted it down that we'll be coming out with certain, some good outcomes that we can, suggest and recommend to policymakers. Thank you so much, Ravi Chandran sir, for gracing the occasion, for being with us, and for making us hear you. Thank you so much. It's a privilege. It's an honor.
Thank you, sir.
Thank you, sir.
Thank you, Dr. Ravi Chandran. I think you were there in tropical meteorology from which year to which year?
88 to 97.
I left 78.
Okay.
So I started my career there after doing just my PhD.
Okay.
So it's nice to relate with you.
Okay.
Now we shall see that how best we can collaborate each other, because our department, AIES, Amity Institute of Environmental Science, Environmental Studies, have now made its stamp actually, and we are trying to understand the different facets, which are interacting and interfacing each other. So on the one hand, we are working on the natural resources. On the other hand, we are working on the wildlife. On the other hand, we are working about the pollution. On the other hand, we are working on the ocean, coastal areas. So we are trying to understand the different types of interactive phenomena that takes place over there and how to integrate them. And your lecture was superb and has given the guidance and direction of the 3 days conference, 3 days workshop come training program, how it is going to be conducted, how it is to draw a conclusion, what is the take homes the students will be getting it, and what will be the recommendation to the policymakers. And I could see that a large number of students are attending it, large number of participants have attended it. I hope that your help, your contribution, and your recognition to Amity Institute of Environmental Studies will go a long way. And I would certainly like to meet you, being the, I would say that alumni to sab thik nahi rahega, but working at the same place. So I was knowing your predecessor, Dr. Naik, who were in so many of the committees for the selection of the directors of the Ministry of IT. So we shall catch up with each other, yes, and we shall see how best we can work together in this very, very noble area, and which are going to be the future of research to me, future of the research. Thank you, sir. Thank you, Dr. Ravichandran. Thank you very much, sir.
Thank you so much, sir.
Thank you, Ravichandran sir.
In fact, there are participants from 11 campuses here, and under the vision of Honorable Founder President Dr. Ashok K. Chauhan, we have a global warming and climate change cluster, so which is directly in line with the mandate of this workshop. So there are participants who are working in this field from 11 campuses of Amity. So thank you so much for joining us.
That's something uniqueness.
Yeah, very unique.
This is all due to our vision of our Honorable Founder President.
Yes.
All
Thank you so much.
Thank you so much, sir. Thank you, everyone. And we have come to the end of our inaugural session, and it was wonderful listening all the eminent speakers. And it's truly a very overwhelming moment for all of us that we have this opportunity to learn from the experience of such wonderful scientists that we have in our country. Now, I request Dr. Manju Rawat Ranjan, Joint Coordinator, Amity Institute of Environmental Sciences, Amity University, Uttar Pradesh, to please extend the vote of thanks to our August gathering. Ladies and gentlemen, Dr. Manju Rawat Ranjan.
Thank you, Dr. Amrina Sadar Khan, for inviting me. Thank you very much. Namaskar and very good afternoon and Happy New Year 2022 to everyone. All the respected dignitaries, guests of honors, distinguished participants, and my dear colleagues. We are thankful to Indian Meteorological Society for collaborating with us for 3 days workshop training program on climate modeling and remote sensing application for environmental systems from 6 to 8 January 2022. Thank you very much. It is a privilege and great honor for me to extend a formal vote of thanks to all present here on behalf of Indian Meteorological Society, New Delhi, and Amity Institute of Environmental Sciences, Amity University, Noida, for attending 3 days workshop and training program. Thank you very much. It is my great honor and privilege to the entire Amity University for convey my deep regards and thanks to Honorable Founder President Dr. Ashok Kumar Chauhan ji for his continuous guidance and encouragement to all of us. My deep regards and thanks to respected Chancellor Sir Dr. Atul Chauhan ji. It is his vision and leadership that has placed Amity University among the top university in the world. My deep gratitude to Honorable Vice Chancellor Professor Balwinder Shukla ma'am for her incredible leadership for straying all the way through for successful execution of all programs done till date by us and continue to encourage us for the same. Thank you, ma'am, for discussing with us the climate impacts on sustainability of life on Earth, impacts on aquatic animals by the pollution which is happening on the atmosphere. I wish to express our great gratitude and appreciation to our guest of honor, Dr. M. Ravichandran, Secretary, Ministry of Environmental Sciences, New Delhi, for gracing the occasion and highlighting the important points. Thank you, sir. You have discussed mapping of changing in ocean, interaction between the land, ocean, and atmosphere for weather prediction, atmosphere modeling, and how to reduce uncertainty in weather prediction, improving the existing modeling. Thank you very much. We have learned a lot from your address. My thanks goes to Dr. Mrityunjay Mohapatra, sir, President IMS, Director General of Meteorological IMG, Government of India, for collaborating with us for workshop cum training program, where knowledge from eminent speaker on climate modeling and remote sensing will be shared among the faculties, research scholars, and students. Naturally, the
Manju ma'am?
knowledge gained.
Manju,
Yes,
just
sir.
I like to make an announcement, and it is
Yes,
our
sir.
honor, rather we are privileged, that whole of the
Thank you, sir.
program, Ravichandra ji, already he is there, the Secretary, Minister of Art Sciences, and others, and the eminent persons like Mohapatra ji and Patnaik ji. Honorable Founder President was following this lecture, but he could not join it because he was busy in other
Sir
areas.
is joining. Sir, sorry to interrupt, but we just received a call from sir, and sir is joining us.
Sir is
It's our
joining. Oh,
honor. Yes.
that will be great privilege. That will be great privilege, great honor actually.
Yes, sir.
Good to know that.
Yeah.
It's great honor for all of us, sir.
Yes, exactly.
So should we wait for him, sir?
Yes, ma'am. Sir is joining us in.
Okay.
Bandapade sir, please go on, because I think it was a bit confusion. Sir is not here, but he's watching us throughout. Yes, sir.
He'll join.
No, sir.
Okay. Thank you. Yeah, I think Sir is totally busy in some other important meeting, and he will not be able to leave that meeting because some delegations have come and he is busy with that delegations of the meeting. But he would have loved to come over here, loved to say hello to Dr. Ravichandran, hello to Mahapatra ji, and hello to Patnaik. But he's totally engaged in some other very important. So on behalf of Amity University, on behalf of the Amity Universe, on behalf of the founder president, once again, we say that we are thankful to IMS and we are thankful to IMD for coming out. And Ravichandra ji, and as we already mentioned, we must now walk together, and we have made a single step of our journey, and we have to walk a mile. I mean, that's the way how I would look at it, because it's a great beginning, and let us make up this beginning further. Let's make this journey further. So now you carry on.
Okay, thank you, sir. Thank you, sir. So I'll continue with my vote of thanks. My thanks goes to Dr. Mrityunjay Mohapatra, President IMS, Director General Meteorology, Indian Meteorological Department, Government of India, for collaborating with us for workshop cum training program, where the knowledge from the eminent speakers on climate modeling and remote sensing will be shared among the faculties, research scholars, the students. A large number of gatherings we can see here with us today. So it's thanks, sir, for discussing with us the tools and technologies which is required for the right prediction of the weather forecasting and the numerical weather predictions, which you have discussed with us, the complications and the numerical, which we have to do a lot of numerical modeling or the analysis for prediction of the weather. The cyclone development dynamic involves in the atmosphere prediction. Thank you for discussing all these points with us, and then surely the knowledge and the which has been gained from your address will help these students to go ahead in their practicals and go ahead in their research and development work further, even the research scholars too. I thank Dr. D.R. Patnaik, Secretary IMS Head, Numerical Weather Prediction Division, and WPD, IMD New Delhi, for joining us and sharing his experience on the important topic like a climate prediction, variability using the climate modeling, accurate forecasting, and for sharing with us the IMS objectives. And surely we will be a part of your membership And I think the membership is open for the faculties also. Faculties and students, we will encourage both to participate in and join the membership of IMS. Thank you, sir. I thank Dr. V.K. Soni, Scientist F, EMRC, IMD for joining us. I thank Amity Institute of Environmental Sciences mentor, sir, Professor D.K. Bandavaya, Padhaiji, Chief Advisor, FPO, Chairman, Amity Law School for having graced us for his August presence despite of his busy schedule and commitment. Sir is full of knowledge and always provide us best possible guidance. He has explained various modeling for the earth and ecosystem analysis and application of remote sensing in various climate variability analysis. Thank you, sir, discussing all these points with us. My thank goes to Professor Tanu Jindal, Group Ma'am, Group Additional Pro VC R&D Director ETSM for encouraging us always. Thanks for discussing the domain projects on remote sensing. Thank you, madam. I would also express my thanks to Joint Coordinator and Convener of the Workshop Training Program, Dr. Renu Dupa, and Convener Dr. Amrina Sadar Khan for their tireless efforts in preparing the 3-day work events. I would like to thank all the members of organizing committee, teaching as well as the non-teaching staff who has been involved in the various particular exercise for last many days. Thank you very much to everyone. I humbly thank all the participants attending from distinct places on virtual platform for your interest and active participation, which will be a great encouragement to all of us. And we will keep on working if you join and your participation remain in such an enthusiastic way throughout the 3 days events. I would failing in my duty if I do not convey my gratitude to the administration and the IIT and MIT University for the efforts they have made for efficient conduction of the events, for the perfect support, and that will remain. Thank you, sir, because you will be with us for next 2.5 days also. Thank you very much. In the end, I once again thank the distinguished assemblage in this workshop cum training program for their presence among us. Thank you very much, everyone. Thank you.
Thank you so much, Manju ma'am. Thank you very much for that wonderful vote of thanks and expressing the gratitude to the August gathering on behalf of Amity Institute of Environmental Sciences, Amity University of Uttar Pradesh, and Indian Meteorological Society. Thank you so much, ma'am.
Thank you, Dr. Meena.
Thank you, Dr. Manju. Thank you.
Thank you. Thank you, Dr. Renu. Thank you very much.
Ladies and gentlemen, we have successfully finished with the inaugural session for the 3-day workshop cum training program. We'll be meeting again at 1 o'clock for our first session for understanding of human environment systems, climate change research, responses, and thresholds in the Earth system. See you soon. Thank you so much.
Thank you. Thank you, Patnaik sir. Thank you, Mentor sir. Thank you.
So this is the same link that will work, na?
Yes, sir. Good afternoon, sir.
Yes, so same link, na? That morning what you use?
Yes, sir. It will be your first session with you right now. So when you are ready, sir, we will start.
Yeah. Should I test just to share something? No.
Yes, sir, sure.
It is now visible?
Yes, sir.
Yes, sir. It is visible, but it is not on show mode, sir.
Yeah, that I can make.
Okay, sir.
Now it is so.
No, sir. We can see the PowerPoint only.
PowerPoint, no slides.
So the slides
no,
are there, but it is not on show mode.
Would you not in show mode? Just a minute. A minute. Just a minute.
Yes, sir, no problem. Can try.
I think your screen, when it will be on share, then only I will be able to share. I think maybe no.
Sir, nothing is shared from our side right now.
Okay, not a share. अच्छा वो तिशानु है क्या था देखो तिशानु वो साइंटिस्ट वहाँ है. Let me enter micro edge. No, why it is not showing?
So maybe you can share the screen. Maybe the PowerPoint is shared.
Yeah, let me just say from another PC. Let me try.
स्लाइड शो करो.
स्लाइड शो हाँ सर स्लाइड शो किया है.
But Naik sir, आप Control F5 कीजिए.
Yeah, now I have done slide show.
Sir, it's not visible, sir.
No, it's not slide show. It's not slide show.
नहीं actually full view it is there. बहुत धुआं है ना तो सब बाहर है. अच्छा अच्छा. Okay ठीक है. बुला रहे हैं. नहीं नहीं कोई नहीं ठीक है. Let me just a minute.
Now you come out and do again, repeat it.
Yeah, I am doing actually. Let us see. Okay, sir, I am just sharing from other PC.
Puneet sir?
Yeah, just I'm sharing from other PC. Just a minute.
Take presentation and you can share your files.
Puneet sir, can you just send the link to Usha Meena ma'am once, please?
Usha
Meena ma'am.
Okay, ma'am.
Now, can you see now? It is okay.
Sir, it's not on show mode.
Is it still? I don't know why it is.
So, may you please share your screen?
Okay.
Maybe it is the PowerPoint that is shared.
Okay, I will share the screen.
So now it is showing.
So now
Okay.
it's showing, sir. Now it's showing, sir.
Thank you, sir.
Thank you, sir.
So could we ask you to please unshare and we can begin with our
Yeah,
session
sure,
then?
sure. Okay. Yeah.
Thank you, sir. Renu ma'am, with your permission, can we begin with the session 1?
Yes, Dr. Richa.
A very warm welcome to all our distinguished panelists and participants. Good afternoon, everyone. I, Dr. Richa Nagar, on behalf of Amity Institute of Environmental Sciences, Amity University, greet all our esteemed panelists and participants to the first session of the 3 days workshop cum training program on climate modeling and remote sensing applications for environmental systems. Today, with the blessings of our founder, President Sir, Dr. Ashok K. Chauhan, dynamic leadership of President and Chancellor Sir Dr. Atul Chauhan Sir, under the aegis of our Honorable Vice Chancellor Madam Professor Baravinder Shukla, and under the reverent mentorship of Professor D.K. Bandyopadhyay Sir, Chief Advisor FPO and Mentor AIES. We begin with our journey of discussing the very important topic of climate modeling and remote sensing applications for environmental systems. Environmental systems are important to monitor and control. With the rising concerns of climate change and erroneous weather events, climate modeling has become imperative to predict future events. The growing human impact on the environment has led to the development of new observations and analysis tools to tackle and monitor types, magnitudes, and rates of environmental changes. The focus is on environmental issues in light of climate change and human impact. Education and training is important to impart clear concept building and delivering the weather, climate, and remote sensing applications required for the environment management. Today, we begin with the session 1 with Dr. D.R. Patnaik sir, who has his master's degree in physics from Sambalpur University, Odisha in 1991 and PhD from Pune University in 2001. He joined IMD in 1998. Dr. Patnaik is presently working as head of numerical weather prediction division of IMD, and his areas of interest are monsoon and climate variability, climate prediction, extreme weathers, extended range prediction. He has published more than 75 scientific research papers in national and international journals. Dr. Patnaik's persistent scientific contributions brought him much recognition and award, like Certificate of Merit for Understanding Contribution in the Field of Atmospheric Science and Technology by the Ministry of Earth Science, Government of India in 2011, and Young Scientist Award for the Best Research Paper published in Tropical Meteorology for the year 2014 by IMS. He would speak on the topic climate change and challenges of extreme weather prediction. So we are highly obliged to be welcoming you first with a Tulsi sapling, as is the tradition of ours at Amity University, that we welcome our guest, Dr. Manju Rawat Ranjan, Joint Coordinator AIES, welcomes Dr. D.R. Patnaik sir with a Tulsi, virtual Tulsi sapling, as we cannot give it physically. Thank you, sir, for joining.
Thank you, sir. Thank you.
Yeah. Thank you, Richa ma'am. So now should I share now, my PD?
Yes, sir, please, sir.
Yes, sir.
Is it visible now?
Yes, sir, it is visible.
Yes,
Okay.
sir.
So climate change and challenges in prediction of extreme weather. So this actually I will be talking about the two parts. So how the climate change is changing the extreme weather pattern and prediction part. Since this is a modeling session, means workshop is on the climate modeling and GIS application. So climate modeling part also will come, the challenges how the weather prediction is. in the scenario of climate change. Yeah. So what is the climate? Yeah. So climate system. If you see, climate system is a very complex system. First of all, we must understand that we are dealing with a very complex systems. There are very many processes are taking place. There are so many physical processes are there. Means you see the biosphere, hydrosphere, lithosphere, atmosphere interacting with each other, and also atmospheric gases in the atmosphere, and that is also interacting with radiation. Then the process of cloud formation, convection, and the soil processes, then ice, sea, all these complex, it is interacting with each other. So when we are dealing with such a complex system, that means we are going to face the challenges. That's why this is a challenging thing, because we must understand that everything interacting. There are, we call it non-linear systems. It is nothing a very linear system, so where we can predict just like x plus y is equal to something. So it is not like that. So it is just a complex system. We are dealing with a complex system. So climate change is leading that complexity. That means increasing that complexity. Okay. So another part is that climate system. Let me say, yeah, this already you have seen this, and this interacting and variability and change. So what is the variability and change? So people are a little bit not able to distinguish what are the climate variability and climate change. So climate variability means year to year variation. Some of this season is very high temperature, a very rainy season. A next winter may be very cold. So this will be calling a climate variability. But if there is a persistent systematic change for a longer period over a larger area, then we call it, it is a yes, climate change. That is systematic for long period. So WMO consider 30 years as a minimum for taking these changes into consider it a climate change. Now this is a well-known fact. The global warming is there. Means climate means carbon dioxide increasing. Now, yes, if you see this last year, about 415 ppm. So gradually after industrialization, around 75. So that way it started increasing. So that is going on. As a result of this, we also over on an Indian scale, if you see Indian region, that is also reflected how the temperature is systematically increasing. So that what a global scale. This is overall means land part of India, and this is prepared by our climate office in Pune. So if you see here, means systematic rise of temperature, decade-wise also rise, and this recent 70 means something like that. That is more here, more means prominent during last 10 year, last 15-20 years climate. How it is related to extreme weather? There is systematic change. Whether really how it is related means it is not a very easy thing, global warming, that to relate to weather, extreme weather. But yes, we have first of all we have to see that India is surrounded by severe weather systems all over, not all throughout the years. If you look at that now, this is the winter season. So yes, WD western disturbance are there. So here. Yes, so western disturbance is there, and then that will give northwest India now also have extreme snowfall is taking place over extreme North India. So that means snow also. That's slightly mid latitude type of thing. Extreme snowfall is also there. This is the winter season. Then when you come to pre-monsoon season, that means thunderstorms. So this is the zone thunderstorm, and this northeast and this Indo-Gangetic area. So it will get a lot of thunderstorm activity. Kal Baisakhi. So casualty also there, lightning, thunderstorm activity in the pre-monsoon, that is March, April, May. Then if you come to the monsoon season, that is June to September, we have very severe rainfall, heavy rainfall throughout the season over many parts, and flooding, all these things you have seen it. June to September, because of all these weather systems. So there, monsoon drop, your mid-tropical cyclone, west coast drop, all these things. Okay. Then coming to the post-monsoon season, October, November, major cyclones are there. Okay, so this severe cyclone, and also pre-monsoon, March, April. So throughout the years, we have your severe weathers are there in over India. And this is how the coastal area vulnerable, large part of coastal areas, storm surge, cyclone, and monsoon, heavy rainfall, earthquake. Of course, we are not discussing here,
But yeah, then flood, moderate droughts also. If there is failure of monsoon, droughts, then the type your thunderstorm, tornado also hailstorms. So okay, so if you see, Miss this India is a land of severe weather, Miss. Okay, and many vulnerable areas there. Sector wise, you can see, Miss, large part is vulnerable drought for flood. So okay, just is and this is the severe scenario. So this is very common during throughout the way, either heat wave, monsoon rainfall, heavy rainfall. But what happening actually? How will associate this thing to the severe weather? First of all, when there is climate change, there is shift in the this was the mean, earlier mean, and now this is the mean. So when the mean this is shifting towards the right, so that means larger area is now under the more hot weather, more record hot weather. So the larger area is now it is getting the severe weather because of the shift in the mean pattern. And the warming climate means there is one thing, one extreme weather most of society and human life. With a warming climate, more high temperature, heat waves, wildfire, and other consequences, fewer cold extreme, more extremes in hydrological cycle. So that is flooding. So this is very common. Instant storm there, hurricane, tornado also there. And if you see some statistic, of course not recent one, but more or less it will be valid. So that means hydrometeorological disasters. If you see that here, extreme weather, okay. So related to both three type of losses: loss of life, economic losses, and also your yeah. So that here, okay, number of events, life loss, and economic loss. So 90% of events, 70% of casualty, and 65% of the economic losses are related to hydrometeorology. That means if hydrometeorological disasters are causing a lot of problem, climate change, and that also is a fact now, and we have to take this into account. Now, observed changes, how we relate to this climate change and rise of severe weather frequency. So temperature and rainfall, if we look at this year, this is a heat wave. Suppose high temperatures are there, March, April, May, June, and these are the area we get it heat waves, and there is increasing trend of heat wave over most part of India. That means we are getting more, large part of India increasing heat wave. So that's why it is there. Means we have seen this thing associated rise of temperature, heat wave is there. Similarly, severe weather rainfall frequency. Yes, so this is also there is increasing trend and frequency of severe rainfall. That means what happened, that means 120 days, some monsoon season is the 122 days. So more number of days are there with no rain or very light rain, but now, but heavy rainfalls are occurring. So seasonal as a season as a whole, that means there is no change in the total amount of rainfall. Of course, there is not significant trend, but contribution or heavy rainfall frequency, contribution of heavy rainfall, now that is increasing at the cost of light moderate rainfall. So that is also a challenging part. That's why this association we have seen it. Climate change is happening, and this is also happening. So that's why we can relate it. This is leading to all this major increase of severe weather events. Okay, so this that's why this is also recent 30-year data also we have analyzed. So rainy days, dry days, and heavy rainfall days. So there is increasing trend of the heavy rainfall days. That is from IMD calculated from based on last 30 years in 1989. So that is documented. That we even. So in future also, future climate scenario also, if you look at here, there is a likely shift of the thing, and as a result, a future projection, there are very models, IPCC there, means here IITM also there. So they have also projected increase in temperature, hot weather, and also heavy rainfall. So this is going to happen. So observe also we have seen, and future projection also see. That means this is the reality and the fact that severe weather frequency, severe weather will be increasing. Now coming to the second part. Challenges of weather forecasting by only models. So since we have already seen what are the challenges we are facing and what are the development we are doing. So since it is a climate modeling thing, I must tell something about the model also. Yeah, okay. So if you say the numerical weather prediction, morning session or discussion was there, it is objective way of weather forecast by solving a set of governing equations. I am not going into detail here. That means evolving variable that define the present state of the. You have the present state of it, set of governing equations, and solving it by numerical methods and objective forecast you are giving. Okay, so of course there are many processes, physical processes are there, all these things, parameters and all this. So here the NWP can give you a objective forecast. Okay, that is the one. Second thing, when we are dealing with different time scale of forecasting, nowcasting, some relevance of the nowcasting for other purpose. Sorry. The very short range up to 12 hours has other significance. Short range 3 days, medium range up to 10 days, extended range 3 to 4 weeks, up to a month, and seasonal forecast 3 to. So that means different time domain we have to consider. So different strategy for modeling is adopted. So when the NWP brief history already missed morning session or discussion and large volume, so it can insert a lot of data. Other no methods can insert means a huge amount of data in the model, capable of handling lot of data and an objective way of forecasting. And brief history, this started long time 1904. That's why I was telling more than 100 years. And slowly there are a lot of failures were there. And then general circulation model also came. Lawrence that sensitive to initial conditions, GCM development, and then recent 30 years, something like that. If you say couple model, then started medium range forecasting, short range forecasting already there. Then 10-day forecasting, ECMW other center, NCMW also started in 88. Then dynamical monthly mean prediction. Then now the ocean model, then couple model, ocean and atmospheric combined model. Then prediction of ENSO, couple ocean, and cloud resolving model. So that way we have evolved a lot, significantly, we have improved significantly in last 30 years. But although it started in 100, more than 100 years back, earlier computer, if you see, just see how much big area, but it was limited power were there, computer resources. But now this, when we are solving this thing, governing equation, numerical procedure, approximate physical process, initial and boundary conditions. So considering that one, consider that we have to, as I said, different strategy has to be adopted for prediction of different time scale. Now casting to short range something. Yes, initial condition up to 1 week, this short to medium range. Initial condition is very important, how we are getting data from different platforms, and then we give the prediction. Then when you slightly increase the time scale, that 2 weeks monthly, this is a something boundary value. SST also, sea surface temperature, that's why we need help of couple model. So all these models means different strategy are adopted for different models. In IMD, suppose there are 4 components are there for a successful thing: observations, communication, analysis, and forecasting, and dissemination. So if you see observations with various platforms, you will get. Communication means it has to come in time to your network. Then analyzing and forecasting, huge data has to be analyzed and do the simulation and run the model, so the forecasting will be available in time. Then dissemination. That way, all the systems are integrated for having a good modeling and system, and also operational forecasting system. And recently, yes, 2015 we got high supercomputer, that means 790 teraflop, and further again means now 8 petaflops. So this is recent computers are there, and also we are going to increase the computer, because the high resolution, all these things, improvement of model is depending on the improvement of computer system. Means because you need computers, that's why the Ministry of Science has dedicatedly purchased this one, and we are using for weather and climate prediction. And already I mentioned. And another thing is ensemble forecasting, because even the one uncertainty there, how to address the uncertainty of weather forecasting. So ensemble means yes, we have to go for the different initial conditions for the same model, so that error can be minimized, and you have to minimize the error. Ensemble mean, so means that also there. So we are also running ensemble model. And this is the ensemble, different set of initial conditions will give different set of forecast. So ensemble mean is there, and so that it will have the higher skill than individual models. Okay. So now this is the operationally, we have the different models are there. Here up to short range, WRF, hurricane WRF, 4 times we are running 3 kilometer. Then medium range global model, high resolution global model, 12 kilometer we have the at present. 4 times we are running. And GEF, this is ensemble with 20 members. We are, that is also 12 kilometer. Then extended range we up to 4 weeks, 1 month. That also we are running 38 kilo couple model. This is a couple model system, and this is the seasonal forecast for 1 season. So various models are already there, as I mentioned in our. And now presently, if you see, huge data on everyday daily basis are coming from various platforms in the modeling system and assimilated and NCM and web. and 90% satellite data are there. It is assimilated every day in time before the running of the model, and this is the forecast available from different modeling in IMD, short range, medium range, extended range, seasonal forecast. So a lot of products are there for personal use. And just I'm giving some example here. Means how the regional model, location specific forecast. We need location specific forecast also. That's why we are using that WRF regional model, and medium range also. For heavy rainfall, cyclone, we are using medium range. Then as a hurricane WRF, a track forecast. This is a numerical hurricane WRF that also coupled. This is coupled one. Then extended range, I said coupled model. So that we are targeting for longer time scale. This active and break cycle from here. How transition going to break and again revival. So that way it is applicable for hydrological sector and agriculture sector. And yes. So this is the prediction how we are when we are approaching toward the dry phase of the monsoon, that we are using that our extended forecast system, and that is able to give the best guidance for up to 3 to 4 weeks. And it is required for the planning and also contingency planning if in case there is something inside the season, within the season there is some variability that will be addressed here. Then recently, further we started for improving the nowcasting, very short range forecasting. This is high resolution rapid refresh. Means we have a lot of radars are there. So we are analyzing the radar, assimilating the radar, and we are giving the forecast every 2 hours, updating this thing, radar data assimilation, because that only will help you to give the nowcasting type of thing. And we have recently implemented this one, HRRR, rapid high resolution rapid refresh, up to 2 kilometers, so that the mainly severe weather in nowcasting time scale can be addressed. And yes, that we have implemented, but this requires lot of computing resources when you are doing. So here products are, if you see it is easy, but actually it requires a lot of computing resources, and because of the availability, at least we are doing, but still the demand is more actually. Okay. Now for the challenges, if I come to the challenges, till though we have succeeded in implementing high resolution models, we have predicting, but still the challenges are there, because disaster risks are increasing due to increasing intensity of frequency, increasing value of exposed element due to development and demographic expansion. So that means a critical component of climate change adaptation. So when we are going for this prediction, it is not that only simple prediction is useful. Simple prediction model is giving this forecast, that is not sufficient nowadays. Because yes, you have to tell forecaster the need. They need the many other things. Means very detailed informations are needed. Actionable input. Now it called it actionable input. What sort of inputs that can be useful for taking proper action? Suppose if you are evacuating coastal belts in the cyclone timing, where you should do the focus, where you should do the evacuation. You cannot go on evacuating 500 kilometers, 1,000 kilometers. Okay, that is very difficult. Okay, for any state government. So actionable, suppose pinpoint. So that's why forecast accuracy also has to be there. Then only you can do the disaster management. Now the challenges. If we come to the challenges, here that means actually here this error doubling time, because whatever global warming is there, rise in temperature, increase in evaporation, increase in moisture content of atmosphere, increase small scale, mesoscale convective systems, formation low, and increasing rainstorm. So that's why now the moisture holding capacity increasing of the atmosphere because of rise in temperature, and and already convectively unstable, atmospheric convective unstable, because the degree of convective instability also increasing. As a result, we are getting more downpour, heavy rainfall. And coming to the prediction part, average error doubling time over central India. Here, if you look at here, error doubling time over central India and frequency of extreme. Frequency is increasing, but average error doubling time is decreasing. That's why, that means very soon in the model, you will get the more error. So you will reach. That's why this is a challenging job, how to do the forecast. Recently also, there is Chennai rainfall was there on 30th, 31st December. It was a very high rainfall because of the mesoscale also in the large scale. That's why sometimes it is very difficult for the model to capture all this variability. That's why we are going for the nowcasting also. And these are the challenges. And challenges means predictable mesoscale system in due to global warming, the prediction of extreme rainfall is likely to decrease. Error doubling time, as I mentioned, even during the 30 years, decreased from 3 days to 1.5 days. So these are the challenges. So solution to improve, how we improve this one? Enhancement observation, you have to improve the observation. Data assimilation, model data assimilation has to be there. This model data assimilation means what all the data should come here. Then as you have seen this, means huge data satellite, high resolution that we are doing, ensemble modeling that also we are doing, capacity building of forecaster, disaster managers, media, and general public, because this is also very important, how you communicate this thing, and capacity building. They should interpret correctly. They should not, because forecast, the forecast, this is a communicating forecast and warning. Is also another science, branch of science. Actually, how you communicate it. Uncertainty has to be communicated clearly so that it can be utilized. That's a capacity building. So all these things are required as a comprehensively. Then only we will be able to address this prediction of extreme weather in the models. So forecaster is doing all this part. They are taking the model forecast from different platforms. It is available from IMD, NCMDL, IITM. Then numeric model, then numerical forecaster. There is two-way exchange. Forecaster will assess the forecast. Also, will see the current situation. Then final forecast he will prepare, and then it will go to decision maker. So that action, then he can take action. So this is a total flow. How is it flow? So that the proper action can be taken by the disaster manager. Then, as I said, the challenging area is another thing that even though we are going for a forecasting, model can give the forecasting, but still the model, what the forecast, suppose 20 centimeter rainfall you are making for giving forecast, 20 centimeter rainfall over the some hilly region and 20 centimeter rainfall in some plain region, it will have different impact. The hilly, it can lead to the landslide, it can lead to the other thing, so other type of disaster. So multi-hazard, one disaster can cause many disasters. Means, okay, so its impact, what will be the impact of that severe weather? So that now the user is not interested only to see the forecast accuracy. Its impact also they are expecting. That means if you are there, yes, it will be landslide. Then you have to specify that these are the area it will have landslide because of the rainfall, something like that. If it's cyclone, these are the okay storm surge, so that these are the low-lying area will have storm surge of 1 meter. So the impact, but for that it is not a single department job. Means IMD is a forecasting part, but you need various other information inputs from other geophysical inputs. Okay, and GIS. That's why I think the GIS as this is also some of the remote sensing application, particularly for this severe weather forecasting, and the remote sensing is also very useful, and people are already working on this thing, and we are using this one. In summary, last slide, climate change is leading to increasing frequency of extreme weather. Okay, the risks of climate change are inequitable. With developing countries like India will be impacted more. MOES, Ministry of Earth Science, through joint efforts of IMD, NCMDL, IITM, and INCOES, taken many steps toward improving the early warning of disaster weather in recent time by implementing state-of-the-art numerical models. That we are not behind anybody. So we have already implemented high-resolution model. Impact-based forecasting will be very useful in minimizing the adverse impacts of severe weather through effective disaster management. Thank you very much. Thank you.
Thank you, sir. It is very enlightening to hear from you. You have given us such an in-depth knowledge in this sector, and thank you so much, sir, for giving us this brief. Sir, we have a question. Would you like to answer it?
Yeah.
Ms. Uma Mufti is asking, what is the best data set for the weather prediction?
Best data set?
Yes, sir.
Yeah, if you see, we are using, as I one slide is that we are using data from various platforms, space-based observation. As I said, 90% of the data are from satellite that are coming to the model. But what if you look at the modeling part? Yes, we need all type of data: satellite data, buoy data, surface observation, pilot observation. Okay, all these things data. But if you go for a certainly, let us say, now casting, you want to go for 3 hours forecast something, yes, radar will be very beneficial. Radar observations, continuous monitoring tracking tool, and radar data if you assimilate in HRRR, then nowcasting. So different type of data are required, but in model, all the data are assimilated. That's why NWP has the unique benefit that it can handle a huge amount of data, okay, from various platforms. So we need all type of data in the model, and for forecasting on day-to-day forecasting specific to as per the requirement.
Thank you, sir, for addressing the query. And thank you, sir, for joining in and enlightening us, and for the partnership and collaboration with Amity Institute of Environmental Sciences for conducting this workshop. So we are very blessed to have you with us, sir.
Thank you, Patnaik sir, for gracing
Thank you,
us
sir.
and giving in-depth knowledge of the climate modeling, sir. Thank you, sir.
Okay, thank you, ma'am.
Thank you, sir.
Thank you, sir.
Thank you.
Today, we are very happy to have with us Dr. A.K. Lohani, sir. Lohani, sir.
Good afternoon. Very good afternoon to all of you.
Good afternoon, sir. Good
Am I audible?
afternoon.
Yes, sir, you're audible. Good afternoon, sir.
Good afternoon.
We are very happy to welcome Dr. A.K. Lohani, who is currently serving as Scientist G in the Surface Water Hydrology Division of National Institute of Hydrology, Turkey, and as Head and Coordinator Center for Flood Management Studies, NIH Guwahati, Coordinator Central India Hydrology, Regional Center Bhopal, Training Coordinator, World Bank aided National Hydrology Project, and Coordinator Decision Support System Planning and Management under National Hydrology Project. His areas of research are rainfall runoff modeling, flood forecasting and flood management, dam break flood analysis, glacial lake outburst, flood management, and design flood estimation. Sir, we are very happy to welcome you with a virtual sapling, the Tulsi sapling that we have a tradition of offering to all our distinguished guests. Mr. Naresh, could you please play? Yes. Thank you. Dr. Renu Dupar, the Joint Coordinator AIS, gives you the virtual sapling as we cannot do it physically in the present times. Sir, we welcome you with a warm heart and we are very happy to have you with us, sir.
Thank you,
sir.
Thank you. So shall I start?
Yes, sir, please.
Okay, I'll share my screen. Just a minute. So it's all visible?
Yes, sir, it is visible.
So I'll be talking about the geospatial information support decision support system for water resource planning and management. So this is basically when I talk about the decision support system in water resources. So first of all, we have to look about the uses of the water. Okay, and why an integrated system is required for making a decision in water sector. Okay, so if you see when we talk about the water, so in case of the water, basin is the basic unit for the management of the water. So if you see in this figure, here I'm talking about the basin. In the basin, there are a number of activities takes place which requires the water, from irrigation to industries to municipal water supply, then recreation purpose, some religious purposes. Okay, so number of things are there. Then the cattle require the water. So number of things, for the number of things water is required. And accordingly, if you see on the right side, a number of departments in our country, they are dealing with the water. Okay, so one is the agriculture department, livestock department, forest department, rural water supply, urban water supply. Okay, so likewise, Ministry of Jal Shakti. So number of departments are there. So which are they are dealing with the water because all they need the water for various purposes. Okay, so basically when we talk about the water, the management of the water is very, very important thing, and how to judiciously supply the water to various users. So here there is a linkages of the water sector. So if you see in the center, the water resources is there. So water resources has linkage with the energy, then the environmental means the pollution and the ecology, social and public health. Then the risk, we have the extremes of the in the water, like the droughts and the floods. So these are the certain risks are there. Then in case of the transport, water is being used, then the urban water supply, agriculture, and there are certain national goals are there for the drinking water and the food security. So there are a number of linkages are there for the water sector. Okay, when we talk about the water, so dealing any hydrological problem in case of the water resources, there are two scales. One is the temporal scale and another one is the spatial scale. So we have to see in which scale of problem lies. Okay, so once we are talking about the flash flood management, so we have to see that the temporal scale is very small in case of the flash flood, as well as the spatial scale is also very small, because this flash flood basically when it occurs in a very short interval of time. Okay, and for a very small basin. Okay, so that's why both spatial and temporal scales if you go for climate change, so it has a very, very large temporal scale as well as the spatial scale. Okay, you can't talk about the climate change on a daily scale or the hourly scale. So you have to go for that century or decadal scale like that. Okay, so likewise, first of all, we have to be very clear about what type of problem we are dealing in case of the water. Okay, once we talk about the water and the management of water, so if water scarcity is there, so what to do? There are two ways of the managing the water. One is on the individual capacity, and another one is on the collective basis. Okay, so individually, one thing is that on the left side, I mentioned that the conservation, and another on the right side is the expansion. Okay, means the supply side management or the demand side management. So left side hand side is the demand side management. So we are managing the demands. Okay, so at individual basis, how we can manage the demand. One is one can adopt the micro irrigation system, reduce the return flow. We can develop the on-farm storages, change the cropping pattern, crop varieties, crop techniques, and the calendar. So this way, an individual can help to conserve the water. Okay, and on the other case, expansion of the water supply. Okay, or the supply side management, an individual can go for the tapping the groundwater, conjunctive use, or recycling. So these are the individual can do these things. Means the conservation of the water, means the demand side management and the supply side management. And similarly, on the collective basis, what we can do on the demand side management means the lining of the canal, improved dam management, water pricing, sectoral allocation. So all these things can be done at the collective basis. Okay, and on the supply side management, one can go for the build more reservoirs, tap groundwater, interbasin diversion, gate man drains, water treatment, and desalination. So these are the things what one can do individually or collectively to manage the water. Once we talk about the water resources, there are three daunting challenges are there. One is the resource-wise complexity is there, then the society-wise complexity is there, then the economy-wise complexity is there. So as far as our country is concerned, if you see, when I talk about the resource-wise complexity, so in case of the water resources, the prime source of the water is the rainfall, and rainfall has both spatial and temporal variability. Okay, so because of the spatial and temporal variability, you should just see there is a very high complexity in managing the water resources, because in our country only the rainfall takes place mostly in the monsoon season, and within the 2-3 months, whatever the rain we are getting, we have to manage the water for throughout the year from that rain. Okay, so that means the resource-wise complexity is there. Then another part is that at one place we do receive the very high rainfall, and another areas we don't have much rainfall, means the drought-like situations are there. So in the country, especially also, you just see the lot of variability in rainfall is there. So rainfall have variability both in as temporal variability as well as the spatial variability. So that's why resource-wise complexity is there. Then another thing is the society-wise complexity is there. So our society is very complex. So somewhere we have the different food habits. We do require a lot of water for the agriculture purpose, means we are consuming the more wheat. Some places, in some places we do consume more rice. So rice is more water consuming crops. So that's why our society is also very complex. So our food habits and other things are different. And that's why our water requirement is different. So that's why I mentioned here the society-wise complexity is also there. Then the another thing is economy-wise complexity. Economy-wise complexity means that in our country, some people are very, very poor people. They have very small land holdings. And another group of people, they have the large land holdings. They are very rich. So that's why the water requirement, water demand, and management of water is different for different persons falling in the different economic line. Okay, so that's why that also has a different complexity. So once you are talking about the management of the water, you have to take care of all these complexities. So here the decision support system, when we talk about the decision support system, so this is the framework of the decision support system. So in the framework of the decision support system, one is the knowledge base, which consists of the GIS, geographical information system, remote sensing, spreadsheets, databases, documents, web, and other softwares. Then the basic input of a decision support system is the data. Data is converted to information, then to knowledge, and then it goes for the decision making. And the model, we do use a number of models in the decision support system, which are basically the optimization model, simulation model, management model, and the operation model. And the kind of output what we get is the awareness, problem analysis, analysis of the alternative, decision supports, and the collaboration. So these are the different things we do get from a decision support system. So once we talk about the decision support system, so basically decision is a reasoned choice among the alternatives. So the different alternatives we do get, and that is the reasoned choice we can make from the different alternatives. And a DSS is basically a computer-based system that integrates different kinds of the tools and databases. Basically, all those things assist in decision making any specific decision. Okay. So normally there is a misconception about the decision support system. People think that the decision can take decision on itself. Okay, so a DSS cannot take a decision itself. They can help you, they can support you in taking the decisions. Okay, so they can provide you different alternative choices, different scenarios, and out of these scenarios, you can just take a proper decisions. Okay. So here in our institute, in National Institute of Hydrology, we are developing decision support system planning and management. And there are various components of decision support system planning and management. One is the surface water planning, integrated operation of the reservoir, conjunctive surface water and groundwater planning, drought monitoring assessment and management of surface water and groundwater quality. So if you see about the methodology of the decision support system, so decision support system has three main components. One is the hydrological model. So in a decision support system on hydrological, when we talk about the management of water resources, a hydrological model is very important model in a decision support system. So we call it as a soul of the decision support system. Then another part of the decision support system is the allocation model. Means once we know that how much water we do have, so how to allocate this water to different users. So normally in our decision system, what we have used the Mike basin as an allocation model, and this is the heart of the decision support system, we can say. And then we have the decision making tools, means the DSS is used to analyze different scenarios. So we call it as one can call it as a brain of the decision support system. So these are the three major components of a decision support system. So this is the kinds of hydrological model we use to assess the availability of the water in a basin. So okay, as I mentioned that the water is to be managed at the basin scale level. Okay, so basically the basin is a basic unit of a water resource system management. Okay, so here I mentioned that this is a basin, then different kinds of hydrological models you can use for assessment of the water or the availability of the water resources in the basin. Okay, these models may be the conceptual model, they may be the black box model, they may be the physically based model. Okay, so different kinds of model you can utilize for making the assessment of the available water in the basin. So here specifically in our decision support system, we have used the NAM model for making the assessment of the water resources. Okay, so basically in this NAM model, the basic data requirement of the model is the precipitation as an input, then the temperature time series and the evapotranspiration time series, and then the observed discharge time series for the calibration and the validation of the model. And from this model, we do get the catchment runoff. So means we can find out that how much water is available in the basin. Okay, whether a basin is water surplus or the water deficit, then we do get the subsurface contributions, means the base flow, interflow, then the actual evapotranspiration, groundwater recharge and levels, and the soil moisture storage content. So these are the some of the information we do get from this model. Okay, so now once you have this model, you can calibrate the model and validate the model for the catchment. And after calibration and the validation, these are the some of the results of the calibration and the validation of the models. Once you have calibrated and validated the model for the basin, you can apply this for the other periods of the data set. Okay, this is the river basin model concept. So once we have developed a model in the decision support system for the assessment of the water resources, then another part is the allocation of the water. So we have to find out how many, what are the users, how many users are there in the basin. Okay, what kind of water, how they are using the water, whether they are the irrigation water user or they are the municipal water user or the industrial water user. So all these users you have to just identify and define. And after identifying and defining these water users, you have to just find out how much water we have to supply for a particular user and for a particular time period. Okay, so all these things you have to do. So this all you can carry out using an allocation model in the decision support system. Using that allocation model, you can just find out how much water is to be allocated to different users. So this is basically in the decision support system. What we do, we just integrate different kinds of the model. Means that either here the surface water and the groundwater models are integrated. Means the rainfall evaporation you just find out. Then the land use, effect of the land use you can just see. You can utilize the topography of the catchment. Okay, what are the anthropogenic effects? Then the soils. Then the groundwater information, the shallow groundwater table, deep groundwater, what is the effect in the deep groundwater, then the runoff, how much the runoff is being generated, then the channel network and discharge. So all those things you can just use in the model. Then in the decision support system, this is the basically the methodology of the decision support system, how it works. So you can use the data sets from the spreadsheet, dashboard, ThinkGeo, Mike time series, okay. Tools, Python you can use, C++, PostGIS you can use. So this is basically goes all these information when the tool in the form of the tools, spreadsheet, GIS scenario development, and the web GIS scripting. So this goes, and then this information goes to the DSS platform. Okay, then it goes to the server. For the data management, you can use the RDBMS or the PostSQL server or the Oracle you can use. Okay, then you can utilize the various modeling tools like MikeHydroBasin, MikeSheet. Okay, and then you have to have certain system for the data backup and the data management. Then you can generate the different scenarios in the model. So here is the decision support system planning and management homepage, what we have developed in National Institute of Hydrology. We are just going to release this very shortly. So this is the homepage of the decision support system planning and management developed under National Hydrology project. We have developed with this system. So this has the homepage, then the dashboard, knowledge base, then the basin planning, flood modeling using the HACRAS, then the head KHMS, then the flood computation using a NAM, then the drought, then the reservoir, then the reservoir simulation. Okay, likewise, we do have number of tools. So first of all, once somebody is using the decision support system planning and management, he has to register in the model. After registering, he can log into the screen. Then we have the different dashboards like the knowledge base, surface water and groundwater modeling, flood assessment, drought assessment, reservoir optimization, water quality. We do have all these models. Okay, so these are the different models are available in the model. So functionality of the knowledge base. So first module, which is the knowledge base. So we have different functionality of the knowledge base, like the we have different kinds of the data available in the knowledge base, like the rainfall data, TRMM data, GPM data, CHIPS data, GFS data. Then the vegetation, we do have NDVI, VECI from MODIS. Then the evapotranspiration, PET, ET from MODIS, and the climatic research unit. Then we do have the soil data in the system in the knowledge base, like and the soil water index from Amitop. Okay, so likewise we do have, then the knowledge base also contains IMD graded data for rainfall and temperature. Knowledge base contains kilowatt data for all parameters, and user can visualize data on map or download it in the form of the netcdf file. And user can also download time series data for all catchment in the CSV format. So these are the functionality in the knowledge base. Okay, so these are the data in the knowledge base. So one can download the data at India level also from the decision support system directly. Okay, and one can process the data at India level, so they can find out the NDVI and other information. They can just simply process, and different basin level also they can go. And this is the GPM rainfall and SPI for the pilot basin. So we have just to test the model, we have just used the pilot basin as the Krishna basin as a pilot basin in the model. Okay, so this is the GPM rainfall and SPI for the pilot basin, then GPM rainfall and SPI for the pilot basin again. So these are the different figures. Then the NDVI of the pilot basin, then the soil water index for the pilot basin, then the visualization of the time series. You can just visualize the time series of the data. Okay, these are time series tools you can use. So there are number of tools are available for the time series analysis. So these are the different categories of the tools available in the knowledge base. So different functionalities are there in the knowledge base, and you can utilize these tools for various purposes, for the various time series analysis purposes. Okay, then we do have in the dashboard other functionalities also. As I'll mention here, there's a surface water and groundwater planning module is there. In the surface water and groundwater planning module, one model is there, the Mike Hydro Basin. It utilizes the Mike Hydro Basin, and the functionality of the basin plan is basically the basin planning module works on Mike Hydro Basin model. User can upload Mike Hydro Basin model and then create various scenarios for the planning. Okay, and they can use the multi-criteria analysis to just plan for the water resources over there. So this is the Mike Hydro Basin model we have used here. You can just see here, and this Mike Hydro Basin model. So you can generate the baseline scenarios here. So different users are there in the basin. A number of users are there: irrigation user, industrial user, the municipal user. So all you can define, and reservoir, hydropower, water users, irrigation users. So all these users you can define, and then you can allocate the water to different users. So this is the level area volume table is there, and then you can generate various scenarios. Okay, and you can go for editing the irrigation scheme. What type of irrigation scheme you do require for a different agricultural fields, whether the drip irrigation or what type of. So you can just change and just see the effect of the changing the different irrigation scheme. What is the effect of that one on the water resource planning and management? Okay, and you can add more water supply in the basin just to see what is the effect of the adding different water supply in the basin. Okay, so new water supply users you can use in the model and just see the impact of that new water supply user in the overall water resource management. Okay, so you can connect the more reservoirs over there and see the impact of that new reservoirs. Then another part is the flood assessment. We have another module on the flood assessment. Here we have used the HECRAS model for the flood assessment. So this model again we have applied for the Koyna River model. Okay, so this is the cross section of the river. Then if a certain amount of water or the flood is coming in the river, so how much area is going to be inundated? So these kinds of analysis you can carry out using the HECRAS model. So these are the, then we have the another module in the flood module is the HEC HMS. So using the HEC HMS, you can just find out the rainfall runoff analysis you can carry out in the basin at the basin scale level. Okay, so these are the various outputs. So rainfall runoff model outputs are there from the HEC HMS. Okay, so this is the Koyna test model uploaded in the NI this DSS system. So this is the basically the precipitation, and you can get a number of results from this HEC HMS models. Okay, then we do have the another calculator. We call it as the rainfall runoff calculator. That is the NAM calculator. So directly within the screen itself, once you have opened the DSS at any point, you just click on at any point. It will create a basin from that point, and from that basin you can just go and directly calculate the runoff. Okay, using the NAM model. Only thing what you have to do, you have to supply the rainfall and the ET values at the basin. Okay. And if you don't have those values, you can directly get those data from the satellite images. Okay. And then you from the knowledge base, or some of the data are available from those, you can use those data. So this way you can directly, using this tool, NAM tool, you can directly compute the runoff at any point in the basin. Okay. Then we have, then after once you have generated or calculated the runoff, it will automatically generate a report about the runoff. So this is the report is generated, the complete report, the basin, about the rainfall and all these information it will generate in the report form. Then we have the drought assessment module. So if any specific block, basin, or the area or the district is drought prone or not, you can analyze from this decision support system. So we have the drought dashboard in the decision support system. Using the dashboard, you can just find out whether an area is drought prone or not. Okay. So these are drought dashboard maps and tables you can have. So here is basically what we have used. We have used the criteria given in the drought manual of in our country. We have the drought manual, and all the criteria we have taken from those manuals and applied in the decision support system to find out the drought. So these are the various tools and techniques what we have used in the decision support system. And basically they are using the various data from the satellite data, okay, and various layers. They are managing the various layers using the GIS on the GIS platform. So this is an open web-based system, okay, on the GIS platform. So this all I wanted to tell you about the model. Thank you very much.
Thank you so much, sir. Thank you for your in-depth explanation of the phenomena, and it has really intrigued all of us. Sir, we have a few questions for you.
Yeah, sure.
So one is, what software are used for assessment of water quality and water treatment modeling?
Water quality, we have used the Qual2 model we have used. So I have, because of the time constraint, I have not shown you the results of Qual2. So we have integrated the Qual2 model in this one for the water quality modeling. And another software what we are using is the HECRAS software is also we are using for the water quality modeling.
Thank you, sir. Sir, how can we use neural networks in the water resource management and hydrological processes? That is another question.
Okay, neural network, basically we do use the neural network for various purposes. I've also used neural network in for various hydrological modeling purposes, like we are used for the rainfall runoff modeling. We have used the for the flood forecasting. We are used ANN, as well as fuzzy logic also we are used. Then another when we go for the rating curve, okay, so for the rating curve also we are used, then the sediment rating curve as well as discharge rating curve, one can use the ANN. Then the reservoir operation, for the reservoir operation one can use the ANN. So still these ANN and the fuzzy logic tools are mostly on the research areas. Still the practical applicability are not that much. So we are trying to utilize the practicability of the ANN and DSS, this fuzzy logic also in various purposes. So in future, we will try to incorporate this ANN and fuzzy tools also in the decision support system. Right now, they are not there in our decision support system.
Thank you, sir. Sir, another question is by Ms. Anshu Pundir. What is the tentative date of release of the DSS?
Within 2 months, we will be able to miss by next month, we'll be able to complete by January. But right now, it will be available for the implementing agencies only, or not for the general public. It won't be available because there are different users from the states are there, state organizations, the water resource organization of the states and the central, they will be using. Then slowly we'll release it for the students and the other faculties.
Thank you, sir. Thank you. Sir, another question is, what is the resolution in terms of levels in topo sheets in the model of basin?
Okay, that depends on the availability of the data. Okay, so right now model don't have any constraint about these things. Okay, so if you have the high resolution of the topo sheets, okay, or the topographical data, you can utilize in the model. Then, but another important thing is that at what scale you are working. If you are working on a very larger scale or at a basin scale, you don't need very high resolution kind of things. But all depends on the availability of the data because it's a all generic model. Okay, so it don't have any restriction of the resolution.
Thank you, sir. Thank you so much for resolving the queries of the students. And we are really thankful for explaining such an important software in such detail so that all our students can gain from it. Thank you so much, sir,
Thank
for
you.
joining us.
Thank you very much.
Sir.
Thank you.
Thank you, sir, for giving this occasion, the session one. Thank you, sir. Thank you.
So today we have with us the next speaker is Dr. Gaurav R. Govardhan, Scientist C, Ministry of Earth Sciences, National Center for Medium Range Weather Forecasting, currently at Indian Institute of Tropical Meteorology. His research interests are in aerosol climate interactions, model simulations of aerosol, model evaluation and improvements, mixing state of aerosol, radiative forcing, cloud radiative forcing, and air quality modeling and fog modeling. Sir, we are very, very happy to have you with us, and we're looking forward to an interesting topic that we'll be covering. Thank you, sir, for joining in. We would like to felicitate you with a virtual Tulsi sapling. Mr. Naresh, could you please share on the screen? Dr. Amrita Sardar Khan is offering the virtual sapling to Dr. Gaurav.
Okay, shall I start sharing my screen?
Yes, sir, please.
Sir.
Good afternoon, ma'am. Good afternoon, everyone. And first of all, I thank you all for inviting me for this wonderful workshop. And I take this opportunity to thank all the previous speakers and all the dignitaries that are there for enlightening us on various topics that they have talked about. And today I'm going to talk about from transitioning from water quality, water management to air quality and air quality management. So the topic is going to be related to air quality and air pollution forecasting. So with this very brief introduction, I will right away start sharing my screen and just a second. Yeah, okay. Can you all see my screen now?
No, sir. Yes.
Can you see this presentation here?
Yes.
Okay, let me just.
Yes, sir, it's visible.
All right. Okay. Okay. So first of all, I thank for inviting me and allowing me to present the work in absence of Dr. Sachin Gude, who is our group leader at the Indian Institute of Tropical Meteorology. And today I'm going to talk about an air quality forecasting system. As I said, we are just transitioning from water quality, water resource management to air quality. So for students, those who are attending, they may find some interesting parallels between what the previous speaker has talked of and what I'm going to talk about. So this is basically a collaborative effort between a couple of organizations. One is Indian Institute of Tropical Meteorology. We have collaborators from IMD. We have collaborators from NCAR USA. And with the collaborative effort, we have come up with this air quality early warning system. This is essentially an air quality forecasting system designed for entire South Asia with a horizontal resolution of 10 kilometers. But the beauty of this system is it also gives you very fine resolution forecast for regional air pollution hotspot like our capital, New Delhi, and the forecast can come at 400 meters resolution. So that means, but every 400 meters, you would know what is the air quality is going to be for next 3 days. So that sort of information at such a fine scale is quite unique, and it's no other city in the globe in the world has this sort of fine resolution air quality forecasting present. So in that sense, we are kind of leading the community in terms of air quality forecasting. So I'm talking about air quality forecasting system and how is that related to climate modeling and use of satellite data is something I'm going to discuss now right away. Is this air quality forecasting system makes use of bunch of satellite data. As I will quickly tell you what all satellite data gets into this air quality forecasting system. So this is basically the domain or the study region for this air quality forecasting system, which has been running for last from 2018 to even this year as well. So this basic study domain is comes at 10-kilometer horizontal resolution, and it uses bunch of satellite data. One of the very important satellite data that it makes use of is this near real-time active fire counts from Modi's instrument on board Aqua and Terra satellites. So these fire counts information is basically used to trigger the fire emissions, the basically the particulate matter emissions that get generated from fires, which typically occur in the month of October and November in the northwestern part of India as a result of stubble burning. So especially these near real-time fires are assimilated into the model, and based on those fires, we set off the fire emissions. And as I'll show you, this particular assimilation of fire emissions and fires has a very important role to play in terms of getting the correct forecast. The next important satellite data that we make use of in our system is again comes from Modi's instrument and Aqua Terra, and this is which is called as aerosol optical depths. So aerosol optical depths basically vertically integrated effects of aerosols in radiation. So that particular aerosol optical depth coming from Modi's is assimilated into the model, and this optical depth is in a way translated to PM 2.5 particulate matter at surface, and in a way that kind of adjusts the model to what reality is. So these two satellite data sets actually get ingested into the model to make the initial conditions of the model more and more correct and more closer to the observations. Apart from these two satellite-based observations, the model also makes use of close to 260 stations of central pollution control boards, and these stations give you PM 2.5 and PM 10 concentrations, and our system actually assimilates all those concentrations into the model to get you closer to the observations to start with. Because as we all know, in climate modeling, it is very important to start with the correct initial conditions. As has been already stressed by the previous speakers, that climate modeling is more of an initial condition problem. You need to have correct initial conditions, and all these assimilations actually make sure you have very correct initial conditions. So apart from this fires or satellite optical depth or surface-based CPCB stations, we make use of uh, meteorological data to set the boundary conditions at the models or initial conditions for the met parameters in the models. Those are taken from a climate model, which is GFS. It is and basically that is been run at IITM at a horizontal resolution of 12.5 kilometers. And today I'll be briefly giving you an overview of how all these assimilations improve the performance of the system, and we will then look at how this system has been performing for last 2 to 3 years, and what are the new additions that we have done into this system this year. So first we will see to what extent the assimilation of satellite optical depths, the one which we saw right here, to what extent assimilation of optical depths changed the simulations of this air quality early warning system. So here I show you the Modi's aerosol optical depth on a particular day, and you can see very high optical depth values over northwestern India as well as Gangetic plains. And if you see the model without any assimilation of the satellite data, you get this sort of a picture from the model. And you see this is what satellite shows, this is what model shows, and model does a lot of underestimation. But when you assimilate the satellite data into the model, and when you make it closer to observations and you start simulating, eventually after a while you get very high, I mean relatively higher aerosol optical depths, which will be closer to the observations than you were previously. So there is very clear indication that including satellite data into climate model for this kind of purpose does improve simulations of aerosol optical depth. Just to see to what extent the PM 2.5 in the model gets affected by this ingestion of satellite optical depths, I show you here PM 2.5 in Delhi. I guess it's in most likely in Delhi, and if you see that this is basically not entire northern Indian region basically. So if you see here, here the black line shows you model simulations without any assimilation of satellite data. The blue line shows you PM 2.5 coming from observations, and while the red line shows you the model simulations with assimilation of optical depths from satellite. And you can see how close, I mean, how better you get after you incorporate assimilation from satellite optical depth. This is on hourly basis, while this is on daily mean basis. And you see there is, I mean, very good agreement. I mean, you see compared to what you would have had if you did not have satellite optical depths. So this is the very first indication and very first evidence that satellite optical depths and assimilation of satellite data improves the scenarios. The second thing that we use satellite data in our system is to predict or to identify location of fires in the model. And as I told you, we use Moody's fire count, about active fire count data, and based on the data and based on its confidence level that you get in the models as an attribute, you actually trigger fire emissions in the model, which are based on climatological fin dataset. Fin is another fire inventory data, which actually uses a similar methodology, but they don't give you real-time fires. What they have is kind of a couple of months gap between wind data and today. So what we do is we make climatology of wind data for last, let's say, 5-6 years, and then we make use of today's fire count from Moody's, and then trigger those fires from fin, so that we get more and more realistic picture of fires in the world. So this is one more way in which satellite data is getting used. So as you can see, there are large improvements because of ingestion of this sort of fires. So for example, if you see all over these stations, these are Punjab and Haryana mainly, and you see how close do we get to observations upon incorporating fires. For example, here blue line is the PM 2.5 in the models without any fires, while the red line is PM 2.5 in the models with inclusion of fires that we do, and black line is observations. So here you see how close we get to the observations when we incorporate fires from fin and satellite data. So another evidence that satellite data is very essential in improving air quality forecasting, and air quality forecasting is anyway very essential for especially for the northern region of India, especially during these post-monsoon to winter days. Now, the third thing that I wanted to stress on was, in general, assimilation. I mean, it's not about satellite, but we also assimilate CPCB's surface observations. So, to what extent do they change the initial conditions in the model? When I say initial conditions, so what happens is, every day you start a model at some point of time, you run it for next 5 days. That cycle goes on 24 hours, I mean 365 days every year. So what happens is, at the start of the first day, or basically at the start of every day, you correct the initial conditions in the model, you make use of satellite data, you make use of CPCB data, and then you pull the model conditions closer to observations. And here I show you how much that pull helps you getting closer to observations. So for example, the red line here is showing you what you could have had if you did not have assimilation of any of these data sets. So this is your PM 2.5 in the model, and without any assimilation. And so you see how apart, how far they are from the observed PM 2.5. And now you notice if you pull the observations in, may the satellite be or may the CPC be, how close you get to the observations. And as I said, this is initial value problem, so it's very important to have correct initial conditions. And if you start with correct initial conditions, you are likely to get closer to the reality in forecast. So now this is air quality early warning system, and this is a simple air quality early warning systems PM 2.5 in the model without any assimilation. This plot shows you what happens to PM 2.5 in the model if you assimilate Moody's datasets plus CPCB datasets, and you see what sort of improvement do you get because of assimilation. So all this point is kind of stressing the importance of datasets in general, but also in satellite as well. So now, as I told you, this system has been running for last 3 years. This system is a multifaceted system, basically. So it has a 10-kilometer domain which takes care of entire South Asia and many of the metros in India, basically. But then this entire domain is actually dynamically downscaled to 2 kilometers to cover the northern Indian region, and which this domain is further downscaled to 400-meter resolution to actually focus on Delhi NCR. So, and this has been running for last 2 to 3 years, and you see how fine this 400-meter could go, and how finer details and aspects of air quality can you get with this 400-meter resolution. So that's why this is a multi-scale system, and a very brief overview on the performance of the system for last couple of years. If you see, this is average of the blue lines is average of 43 CPCB stations in Delhi with PM 2.5, and red line is the modeled average for all those stations. And you could see the model can very well predict the trend in PM 2.5 values. It can give you very gradual build-up. It can give you gradual or sharp reductions. It can give you strong build-ups, strong reductions. All sorts of pictures are very well captured by the model with a mean bias of 13%. And I'm sure those who are in air quality forecasting, they would realize that 13% of mean bias is actually very good. Similar evaluation we did for year 2020 and 2021, and you could see the model is doing fantastic. I mean, for example, this is during probably during case of Diwali, you see model could still, excuse me, you could still capture the peaks in Diwali or all those episodic peaks that model could very well were captured by the model and AQAWS. And this system has been very much trustworthy, and a lot of government agencies have been following the forecast from the system, and people have kind of appreciated the effort for the AQAWS for the last 2 to 3 years. So this was all for Delhi, but if you look at some other metros like Bangalore, for example, and which is not equally polluted as Delhi, but it's getting there probably. So if you see PM 2.5 in Bangalore in observations, and if you compare that with PM 2.5 in the model, you see the model quite well captures the variations. Even if you see on the daily mean basis, apart from a few hiccups here and there, you see a lot of days on which model is getting closer to observations. And this is happening at 10-kilometer resolution. Now imagine if we fine it down to 400 meters, we probably would get all these things correct. So there is a lot of potential in this system, and we are going to extend it further in the years to come. Just to show you how good the forecast is, just some statistics. If you see on the first day of the forecast for very poor, so in air quality, there are different categories depending on air quality index. So for very poor air quality scenarios, where a air quality index is going from 301 to 400, if you happen to fall in that range, you see on the first day of the forecast, the model shows very low values of fractional bias and fractional error. May it be 10-kilometer resolution, may it be for 400-meter resolution. Similarly, on the second day or third day, all these biases, errors for area resolution are still within limits. So for very poor air quality scenarios, the model is doing excellent job. For severe air quality scenarios, the model can capture the scenarios on the first day of the forecast. That is, if I'm telling from the basis of model, if I tell you that tomorrow is going to be severe air quality, you are going to be sure almost that yes, it's going to be severe because the biases are very, very less. On the second and third day, the biases go a little higher, but still they are within limits. One of the very important aspects of air quality forecasting systems is statistics, and one of the very important is false alarm rate. How many times that model tells you that there is going to be an event and you don't end up getting an event. How many times that would happen? That is called as false alarm rate or a false alarm ratio, and it's a very important attribute for any modeling system. And you can see our modeling system is doing very good job in that. For unhealthy category, for very unhealthy or severe categories, the false alarm rates are substantially smaller. I mean, these sort of false alarm rates, if you get 0.1 or 0.0 at 0.2, 0.1 at, all those things are totally acceptable uh, for a complex problem like air quality. And you can see the accuracy is also been very good, no matter how good is the resolution, 400 meters or 10 kilometers, the accuracy is more or less similar. So we have created a website, a public dissemination system, I would call it, to display the results of our air quality early warning system. And it's been operational since last 3 years. And one could easily get onto this particular link and see all the products that we have. We have 10 days forecast, we have 3 days forecast, we have forecast for Delhi, for different cities, for entire India. For general public, they can see the bulletin also. All sorts of details are already there when you have observations. For some advanced people like all of you, you probably can explore it more and get into the analysis part of the forecast, where you will see evaluation of the model forecast compared to observation, how it looks like, and how was the, if you see PM 2.5 in Delhi, to what extent fires contributed at PM 2.5, all sorts of, all those details are there in the analysis tab of the website. So this was all, this is what we did till last year. And this year we wanted to come up with something new and something additional to this. And there we came up with this motivation, basically for this decision support system. Our kind previous speaker has talked a lot about decision support system and the philosophy behind decision support system. And his explanation of DSS actually has made my life easier. I don't have to spend time on explaining what a decision support system is. But still, I would quickly tell you what decision support system is. Basically, it is supporting the policymakers to take decisions regarding air quality management. So this is currently, why is this needed? Because we know that during winter times, the air quality in Delhi, especially in northern India, and with the focus on Delhi, goes pretty bad. And we know how often do we get to hear a lot of news reports and news channels. Everywhere we get to hear about Delhi air quality. And one of the important information that the decision makers would need is not only the forecast, but they also want to know in advance that when is the severe air quality event is going to come. Second important thing that decision makers would like to know is what factors are going to be responsible for that severe air pollution event. Is that going to be caused by Delhi itself, or that is going to be caused by sources which are not local to Delhi but non-local sources, or is it being caused by stubble burning that is happening in Punjab and Haryana? All that information the decision makers need to know so that they can act upon it, and this information should be available well in advance so that they have time to act upon it. More importantly, it should also have a facility in which we should be able to create certain hypothetical scenarios in this decision support system, which can tell the decision makers that tomorrow, if you control certain emission sources by certain magnitudes, what is the likeliest improvement that you are going to get in air quality in Delhi? So that is very essential, because if they want to implement something, they should know beforehand what is going to be the effect of it. All these motivational points are included in our decision support system. And very soon I will show you the public dissemination system for it. But before that, I take this opportunity to talk about some of the details of the decision support system that we have developed. So one of the very critical input for this sort of a system is anthropogenic emissions of particulate species, and this we are getting from TERI for Delhi and the 19 districts surrounding Delhi uh, at 4 kilometer resolution. But since we are covering entire northern India, for the other regions apart from these 19 districts plus Delhi, we are using EDGAR emission inventory. A few of you could be aware about EDGAR emission inventory. Uh, Now, as I told you, we are going to give you some sort of a source apportionment in the PM2.5 Delhi. So we need to have emissions, sector-wise emissions, especially for Delhi. So we have sector-wise emissions for following sectors in Delhi, including transport, industries, residential, energy sector, waste burning, construction, road dust, and all other sectors which are not part of all these 7 sectors are being put into others. As so we have 8 broad sectors on for which we have emissions in Delhi. Plus we also have these district-wise emissions in the model, and essentially so how do they look like? For example, in 19th district, the transport emissions more or less look like this. The road dust emissions look like this, and industries emissions, they are kind of Delhi being devoid of industries. You see more industries in surrounding districts and Delhi. So all this is coming from TERI inventory. So all these emissions correctly put into model, what do we do next? Now, since we have to do some sort of source apportionment, we should be able to trace this species, trace the emissions that is coming out from, for example, if I am in Gautam Budh Nagar and I want to know to what extent the emissions in Gautam Budh Nagar affect PM 2.5 Delhi, I should be able to identify emissions from Gautam Budh Nagar. So there is a very established approach that one could adopt in doing that, which is known as tracer approach, or what they call is a tag tracer approach. So what is a tag tracer approach? Now, since this is a workshop come training sort of a presentation, I take this opportunity to dwell on this for a couple of minutes. So what is a tracer approach? So tracer is a passive species in the model. For example, we have a regular species in the model, for example, like black carbon, which undergoes its emission, which undergoes its transport in the model. It interacts with radiation in the model. It undergoes its own chemistry and it gets deposited. A tracer species for black carbon, which is going to be very similar to what the regular black carbon is doing, just the fact that it will not interact with radiation. That is, it will not feed back to the model. Everything else you will see, for example, if I have a total black carbon emissions for the entire domain, and if I want to trace what is happening, what is coming from Delhi, I create that emission species for Delhi, and I allow that species to get transported in the model. I will not just say that, okay, this species cannot interact with radiation, because this interaction with radiation has already been taken into account when total species was considered. So likewise, these tracers do not, you can trace them in the model, and by tracing them, you can quantify their contribution to total black carbon or total PM 2.5. So likewise, making use of the tracer approach, we have incorporated 470 tracers in the model, which basically come for different species, aerosol species, for example, black carbon, organic carbon, and there is something called as P25, which is none of the standard aerosols, but which is something similar to road dust. And also we have incorporated tracers for carbon monoxide. Apart from this, I mean, in addition to the species, we also have district-wise tracers. So as I said, we have tracers for all emissions from all these districts. So in a way, we can trace emissions from Jhajjar, we can trace emissions from Gurgaon, we can trace emissions from Gautam Budh Nagar, and we can see how much of emissions, how much do they contribute to Delhi. All that information we do have. Apart from, we also have how much do the transport sector in Delhi contribute to its own concentrations. Likewise, we can get contribution for all different sectors, emission sectors in Delhi to Delhi's air quality. And as I told you, apart from this, some sort of a source apportionment, we also have these scenarios which tell you that what if sort of situation. So what if I decide to control transport emissions in Delhi by 20% or 40%? What is the likeliest change in air quality? So all this information is publicly available in a website, which I will show very quickly and very soon. But just the overall framework of DSS is, it is very similar to air quality early warning system in terms of assimilating satellite data. That is, it assimilates fire data, it assimilates Moody's optical depth, it assimilates CPCV observation stations. It runs WRF-Chem model at 10 kilometer resolution with 470 tracers. It generates the information which I will just now show you, and this information eventually is accessed or is looked at by the controlling authorities, based on which they can take suitable decisions to manage air quality in Delhi, NCR. So I'll just quickly show you the public dissemination system for DSS, and which has been operational now for last or close to 3 months now. It's been operational. So this is how the DSS website looks like. So the first page tells you the district specific fractional contribution to PM 2.5 in Delhi. So what this figure tells me is, if I'm looking at PM 2.5 in Delhi, how much of it is coming from Delhi itself? How much of it is coming from different districts around surrounding 19 districts? How much of it is coming from biomass burning that is happening in the domain? And how much of it is coming from other regions which are not covered in these districts? And this sort of information you can get for next 5 days. So every day this information gets updated and you get to see these spatial maps for the next 5 days. You know, depending on time of the day, depending on winds, depending on season, this spatial structure would change, but you can clearly notice how different and how slowly it changes depending on time. And this is the time that you see here. But one would want to know at one shot, I want to see what is the Delhi's source apportionment looks like. So this is the map for you. This is for 5th Jan, that is yesterday's model simulations. You can see till around 10th Jan, we have sort of source apportionment for PM 2.5 in Delhi, and you can see how different districts are contributing to PM 2.5 in Delhi. For example, on certain days, you see Gautam Budh Nagar coming up around 14%. On certain days, Jhajjar contributes to around 23%. On certain times of the day, you see other regions contributing to very high values. You see sometimes Bagpat comes, sometimes, I mean, quite a lot of times Delhi transport itself contributes to 20% of Delhi's own pollution. So all sort of information is right there on a click for everyone to see. Apart from this contribution, as I told you, we also have this scenarios sort of a business here. What does it do? So here one can see this is basically what if kind of scenario. So what if I control transport sector in Delhi by 20%? Like what is this telling us? So if I just deselect all of this, I'll show you very quickly. I'll show you how can one make use of this tool here. So if I want to say tomorrow, if I'm a policymaker, right, and there is a very severe air quality event that's going to come in Delhi in the next 2-3 days, I say, okay, let me just see what will happen if I can reduce the transport emissions by 20%, or let's say by 60%. And I get to know, okay, you are likely to get around 12% improvement in PM 2.5 in Delhi by controlling the transport emissions. Same, what if I control the Gautam Budh Nagar emissions by 20% or 40%? So all sorts of information is available here on clicks. So one can play around this and create his or her own scenario to manage air quality in Delhi. And this has been a very important tool, I think, for policymakers. And this year we have been a lot of days that have been severe air quality events, and RDSS has been very useful, and this sort of scenarios tool has been very useful. I'm sure it has been very useful. And this is on a hourly basis, but if one wants to know what is going to happen on daily mean basis, so you also have a daily mean picture available. You don't have to go into different hours of the day, which will tell you what is it like for the entire day, and what is it like if I want to control daily mean behavior, what is it like. So all sort of improvements you can get. You can get to know, okay, 40%, 20%, all this information is very vital when you have a severe air quality event, and especially when Supreme Court has to intervene and take a tour of the situation. So this sort of tool is very important. So that was air quality early warning system, and enhanced version of that is a decision support system. Now, if I have some time, I would want to talk about one more addition that I have. This time we have added to this utility, but it depends on the organizers, and I just want to confirm if I have 2-3 more minutes. Do I have a couple of more minutes? You are muted, I guess.
Sir, as you please, sir.
Yeah, okay. So apart from aerosols that are aerosols also affect not only air quality, but also they affect formation of fog. And when you get to in the month of November, December, you start worrying about fog in Delhi. And why Delhi? Because a lot of flights get delayed by that. A lot of road accidents or train accidents may occur because of fog. And till now, we had a forecasting system for fog, which are not taking care of aerosols available in the atmosphere, because it is very challenging to actually communicate fog formation processes with aerosols in an operational forecasting manner, because the models that are used to incorporate aerosols and fog, they are very extensive in terms of computational resources, and one cannot run those regularly day-to-day basis. So one has to look for some sort of a trade-off between how can one between the accuracy of this aerosol fog interactions and incorporation of aerosols in fog. So this year what we have done is we have made use of an offline a standalone modeling code which was shared with us by UK Met Office. That code is called as VERA, VERA. That is visibility employing realistic aerosols. So what we do is we make use of this code and we connect this code to our WRFCAM, that is to our air quality early warning system. So air quality early warning system has aerosols, it has meteorological parameters. We bring in VERA, and then we make aerosols and met parameters in the model talk to each other, and we get visibility forecast. Now this is the visibility forecast for next 46 hours from yesterday. And so VERA gives you not only the forecast of visibility, it also tells you what is the probability of having visibility less than, let's say here, 200 meters. So what is the likelihood of having dense fog event? All sorts of that sort of information is available in VERA. And if you see, for example, for next couple of days, you see the predicted visibility in Delhi is not going below 800 meters. So there is no chance that one could have, I mean, very little chance of having dense fog event for next day. It also tells you the probability of having dense fog event, but it's not very high. So that sort of information is now available for the first time in YFX or IITM YFX forecast. So this is a new addition. So why did I involve that? Because this also kind of an addition of air quality early warning system, DSS and VIRA. So all they are added to each other basically. So with this, I would like to conclude my presentation over here. So I hope you would have understood or gotten the glimpse of the air quality forecasting initiatives or activities that are going on at IITM in collaboration with IMD and NCAR. So I just close this presentation and open the forum for questions or discussions.
Thank you, sir, for a very deliberative your presentation that you have given. It is so elaborative, and everyone, I'm sure, has benefited from it. There are a few questions, sir. Would you like to answer them?
Yeah, certainly.
When running WRF chem model for surface ozone variations, will we use AOD data? Is it needed for assimilation? How to integrate VOCs data in the WRF chem model?
Right now, we are incorporating PM 2.5, assimilating PM 2.5 and PM 10. But other chemical species and criteria pollutants, we are going to be doing it next year. That's the agenda. So as and when we get into that, we will worry more about those things.
Thank you, sir. I hope,
Yeah.
Priyanka, your query is resolved. There is
Mhm.
another one. What kind of pollution dispersion plumes models used? Is it
Mhm.
backed by field tracer gas experiments?
No. So if you are looking at WRF chem model, so there is no dispersion model as such you need, because it's a three-dimensional model in itself. You don't need any separate dispersion model like what you would need for, let's say, WRF and CMAC. So this itself has its own meteorology and its own emission concentrations, all sorts of things it has. So it's a modeled resolved transport is what disperses aerosols from its source, as I would say.
Thank you, sir. There's
Yeah.
this last question. Every criteria pollutant has an index value. Then which one decides AQI of the day?
Okay, so that actually depends on generally, if you see during winters, most of the times it is PM 2.5 which decides the AQI, especially for Delhi. Sometimes it could be PM 10, or on certain days in summer it is PM 10, but most likely it is PM 2.5.
Thank you so much, sir, for gracing
Yeah,
us and to answering all the queries of the students. Thank you so much,
yeah.
sir. There is
Thank
another one question that Mr.
Uh-huh.
Kesar has just entered.
Uh-huh.
How accurately do these models work over the steep mountainous terrain in case of resolution? Sir, would you like to answer it?
Yeah, certainly. I mean, that's a very good question, because if you want to go on the mountainous region, a lot of these parameters would change, and you would need different model setup, strictly speaking, when you are going to simulate air quality or meteorology over mountainous regions. So a lot of this would change, and that's going to be a challenging thing to do, because when you bring in mountains, a lot of katabatic winds, anabatic winds, all sorts of things would come in. So it will be a steep challenge, as steep as probably mountains are. So we'll have to see when we start simulating for some mountainous regions. I'm sure we will do that someday. We will have to start thinking about making it more and more accurate for the mountain.
Thank you so much, sir. Thank you so much.
Yeah. I guess there is one more question.
Yeah.
Okay, maybe I can just type in my email address here. Yeah, someone wanted my email address. Dr. Uma Mufti wanted the
Yes, sir.
email
Some
address.
PhD scholars and MSc students sponsor email ID so that they can contact you for their further research work.
Yeah, certainly, certainly. I've shared it with everyone. If you can,
Yeah,
you can see.
thank you. Thank
Yeah,
you,
yeah.
sir, for gracing us, and no doubt the in-depth knowledge of all the PM and all the pollutants you have shared in this team. And I'm getting the continuously phone from my research scholars. They are very happy to listen to your lectures, sir. Thank you so much, sir.
Thank you,
Thank
thank you.
you.
It was my pleasure. Thank you. Thank you.
Thank you, sir. Thank you for being with us. Thank you.
Yeah, thank you. Thank you.
Thank you, sir. So
Thank you.
we are moving to our next speaker for the day, Dr. Usha Meena. She is Associate Professor, School of Environmental Sciences, JNU. Her research interests are agroecology, air pollution and environmental impact assessment. She has a vast experience in her field and has published several research papers. Ma'am, we are very happy to hear you. Dr. Yes, ma'am. Thank you for coming and gracing our occasion. And may we please have the virtual sapling. As a tradition, we offer virtual Tulsi sapling to all our speakers. Thank you, ma'am, for joining in.
Thank you. Thank you. Let's share this screen.
Thank you, Dr. Usha, to join us.
Thank you. Thank you, everybody. And today's topic of my talk is on climate change and food security. And as I heard my earlier panelist, Dr. Patnaik, Dr. Govardhan, and Dr. Lohani, so they have all addressed the decision support system. So, but my topic of talk is somewhat little bit different, but I think it's very much, it's centered, all those technologies were centered around this only. So with this, my slides are visible.
Yes, ma'am, but it is not on show mode.
Slideshow. Do it on slideshow.
So why we are discussing, what is the context behind this choosing this topic is that we all know that by 2050 our global population will reach by 9.1 billion, and we need to ensure that our food production should be raised by 70% by 2050. And for that, we should have understanding to transform our global food and agriculture. And we need to have understanding what are the factors which are leading to this transformation and how we can manage them. So the major factors which are transforming the global food and agriculture are we know the population, and in that also the demographic and urban and rural change, that is also very important. Besides this, the nutrition and consumption changes are the factors, then farm size and business and associated technologies, then food system, the changing dynamic food systems. And above of all, the climate change is the major stress factors which come on top. So with respect to food system, as we know, if you want to define, then it includes the people, places, activities that bring us the food. So, and the size of food system varies from the scale at which you are addressing. Since being an individual or food system also include various people, places, and activities which are bringing the food on our plate. Similarly, the food system of the small landholder farmers is also different. Sometimes they only produce the food for their own self-consumption. But at present, that type of situation is very less as compared to that the network, the food systems of all are integrated. So those people, places, activities which make food available in diverse way, and they also influence, not only ensuring the availability, they also influence and our shape and choices we make, that what to eat, when, and how. So the food system activities, major activities, which in brief I am just dealing this. These are the production of food, that is pre-production and production activities. In that we include the production of food, or that activity only ensure the food availability aspect of food security, which I will take later. Then post-production phase, which includes the processing and packaging and distribution and retailing, as well as consumption and waste disposal. So these are the different food system activities which are categorized into two parts: pre-production and production and post-production part. And with this, these are the different drivers who drive our food systems, like the way the production system, then aggregation, transport, storage system, how we are processing, consumption, waste and resource management. And with they have their sub drivers, like production is dependent upon energy, materials, then waste, and consumption is dependent upon the waste, and then loss, business. So all these food systems outcomes, if you want to categorize, then the outcomes can be categorized in environmental outcomes and socioeconomic outcomes, as well as with respect to the food. And this food system is now also along with food security and along with the sustainable agriculture, it is the central part of our SDGs. So all those 17 SDGs can be categorized into those environmental outcomes, socioeconomic outcome, and food outcomes. So you can see in the SDGs number 13, 11, like climate change, sustainable cities, life on below water, life on land, they are the environmental outcome of the food system. Means how our food system, the way our food system is operating, how it is affecting all this environmental attributes. Similarly, the inclusive development socioeconomic outcome is dependent upon no poverty, gender equality, and all this SDGs. And food security is dependent upon zero hunger, which ensure that we will able to achieve the SDG 2, that is zero hunger. Then clean water and sanitation, these are the some of the SDGs. So you can see the food system is, if our food system is stable and sustainable, then only we will able to achieve the SDGs also. So that's why, but at present, the global food system is at crossroads and it is undergoing profound transformation. And I have already told you what are the factors which are leading to those transformation. And since food security is very much intricately associated with food system, so that's why we should have the understanding of the brief. In broader context, we can handle each and every component to make it sustainable and to ensure the food security. So now when we say that the world is producing enough food, but still we are not able to achieve the food security, then what are the reasons behind that? The major reasons behind that though we are producing the enough, but we are not able to ensure the food security because of the problem of access and equity problem. Okay, means people do not have access, and if they have access, then that is not equally distributed. Then there is a socio-economic problems are associated. Their energy issues are there. Climate change is one of the issues which we will discuss today. The natural resources problem is there, and social scientific problems are there. So these are the issues which are acting as a hindrance in sustainable development of sustainable food system. And what defines the sustainable food system is that system which ensure appropriate food production, reduce losses and waste, while also safeguarding human and environmental health, political stability, and better livelihood with less environmental consequences. So you can see, if we have a sustainable food system, then we also have a solution of all the world problems, so in that way, and if we have a sustainable food system, then we can also able to ensure global food security. And how global food security is defined, it's defined as when all people have physical and economic access to sufficient, safe and nutritious food that meet their food preference and dietary needs for an active and healthy life. And in that, the nutrition is an integral and multidimensional aspect of food security. And it also includes adequate diet, health services, sanitation, proper childcare, and feeding practices. So we can say that this climate change, food security, and food system, they are very intricately correlated. If anyone is under stress, if any climate is under stress, so it is ultimately affecting our food system, and the ultimate effect will be visible on the food security. As we all know that within food security, there are its 4 components, that is availability, access, stability, and utilization. And if we will say that food availability is the amount, type, and quality of food a unit, whatever, a home, village, or region has its disposal to consume. And the factors which availability is the function of the production, distribution, and exchange. That how much we are producing, okay, and how well it is distributed, and in what form we are exchanging it. And if further we will go on sub-factoring, then production is determined by resource availability and state policies. Resource availability ensure the natural status of our natural resources which are available on those agroecosystems which are responsible for the production. Then distribution determinant are the post-harvest processing, storage infrastructure, transportation, gender, age, and public safety. And exchange determinants are what is the income level, okay, and what is the purchasing power, then what is the local custom and culture, and social network. So these, you can see that a single component of food security is dependent upon so many factors as well as sub-factors. And now climate change, it has been established that climate change will reduce the global food availability. And in this figure, this is the paper of Helen Gunnar, published in 2016 in Nature Climate Change. They have estimated that this is the average shift in the food availability with respect to wheat, maize, and rice and soybean crops. And due to the change in, due to the enhancement in temperature as well as shifting in rainfall patterns. So it has been estimated that by 2030, there will be 10% decline in global food production. And by 2050, there will be 20%. So this indicates that the climate change will affect the food availability. And once the food availability will be affected, so automatically the all 3 components of food security, that is access, utilization, and stability, they will be affected. Access include the strategies a food unit employ to obtain the type, what type of food they want to, what is the quality of food, and how much quantity they require. So these are the factors which determine the access. And access is dependent upon the, again, affordability, allocation, and preference. And then preference is dependent upon religion, season, advertising, and preparation requirements. And after the food access, the next component is the utilization, food utilization. And it's varies. We know food utilization within family to family varies. Similarly, it varies from one local to region, state to state, or countries to countries. So food utilization is household and community capacity and strategies to consume food. It determines that how sustainable is their food utilization. And food security and nutritional security are interlinked. So it depends. So utilization ke jo subcomponents, the subcomponents of utilization are the nutritional value of food, the social value, and the food safety. And nutritional value, if we want to define that, it indicates that what is the daily requirement of calories, vitamins, proteins, and micronutrients are provided by the food consumed. It determines its nutrient value. And that's it's dependent upon its diet diversity as well as disease incidence. And social value determinants are what are the cultures of the society, what customs they follow, how many holidays they have. And the safety of food is determined by which type of cooking facility we cook, what is the access and availability of safe water and hygiene. So these are the different attributes. And then if all these 3 will determine the stability, okay, food security and stability component, that is that whatever status it, but how long it will be status. But it has been now established that all the food systems are vulnerable to climate change. Food system security as well as vulnerability is determined by the global environmental changes as well as societal change. Okay, both. But out of these 2, at present, the more important factor is the global environment change. And we all know global environment is changing and climate change is reality now. We have evidences that climate change evidences which establish, we all know. So I'm just passing through it, that average temperature of Earth is increasing, sea level is rising, our glaciers are retreating, ocean acidity is enhancing. And we are observing the climatic extremes. They are aggravating, like cyclone. The frequency of cyclone is increasing and their intensity is also increasing. Duration of drought, frequency of flood, drought, heat wave, heavy rains, they both are increasing. So this indicate that climate, along with climate, not only changing the global average temperature or altering the precipitation pattern, but they are also enhancing the climatic extreme events frequency. And all this will ultimately affect our production, which is dependent upon our agriculture. So now if you want to have this agriculture and climate change correlation, so in this, the agriculture also contribute to climate change, and climate change also affect the agriculture. Agriculture contributes to climate change by acting as a source of greenhouse gases. All different agriculture practices are responsible for emitting three major greenhouse gases, which are responsible for climate change, that is carbon dioxide, methane, and nitrous oxide. And due to the after effect, due to this feedback mechanism, the climate change induced elevated temperature and elevated CO2 levels, as well as altered precipitation patterns, are affecting the agriculture. And those impacts of climate change on agriculture has now been quantified also, and it has been established that agriculture, either positively or negatively in different regions of the world, will be affected by climate change. And after the impact assessment, the things will come. Now we have to assess that which regions agriculture is more vulnerable and which regions agriculture is less vulnerable to climate change impact. After the vulnerability assessment, we need to find out the adaptation strategies. We need to find out the mitigation strategies with respect to climate change. So this is the brief that though India only emitting 6.5% of global GHG, and out of those 6.5% of global GHG, the major contribution within India is coming from the energy sector. Agriculture is contributing only 18%, and within that 18% of agriculture is contributed by livestock fermentation, that is 56%. Agriculture soils are emitting 23%. Rice fields are emitting 18%. Crop residue burning is contributing 2%. And the way we are managing the manure is contributing 1%. So you can see that though India's contribution is less, and within that agriculture is also less, but it is significant. So, and there are multiple impacts of global warming and climate disruptions on agriculture has been reported. But if we want to scale, if we want to study with respect to a single crop, or with respect to a cropping system, like rice, wheat is a cropping system, which the pattern of the system in the series in which the crops are grown on a farm in a particular year constitute its cropping system and the farming system, and they all include under food system. So the impact of climate change with respect to crop stand and cropping system is quantified with respect to the impact on the crop's productivity. And when it is compared with respect to farming system, then it is with respect to crop production. And when it is dealt in context of food system, then it is to ensure the food security. So in this way, this climate change impact on food system is quantified with respect to the food security. And we can, the question will be, how will climate change will affect the food security? So for that, we need to find out, we need to have an understanding of our food systems, which I have explained you what constitute the food system, and then vulnerability of food system, that how vulnerable is our food system. And we know the vulnerability is a function of the exposure, sensitivity, and adaptation capacity of a system. So what is, how much exposure of a food system to the climate change, what is its sensitivity, and what is its adaptation capacity. So all these factors will determine the food system's vulnerability to climate change. Okay, and then at different spatial scales, different scenarios will be generated with respect to that, how in different regions food systems vulnerability is there, and how the socioeconomic factors are integrated will be affected by So in this, and how biophysical models will help us in estimation or in creating the forecasting to reduce the vulnerability or to minimize the impact of climate change on those systems. So these are the different researchable issues which are addressed at different scale. So if we want to come to an agroecosystem scale, so climate change effect on agroecosystem are of both types. They have positive effect as well as negative effect. Because if on a planet Earth scale we will see, so at all places the climate change will not negatively affect the agriculture system, or not at not places or all places it will have a positive. So we should have what are the positive effects of climate change, that it will increase the productivity from warmer temperatures. Like in European countries or those temperate region countries, they get a more window period for growing the crops. So their productivity will be enhanced. Moisture stress will be decreased. Then possibility of growing new crops will be identified. These are the positive. Then accelerated, the crop maturity duration got shortened. Then growing season will be longer growing season, which I have told you, longer growing window period will be available for those temperate regions. And sometimes CO2, due to certain CO2 fertilization effect, the increased productivity will be observed for some crops, but it is not for all. Only those crops which will respond to the elevated CO2. Similarly, the negative effects of the climate change will be, there will be extreme heat, crop damage from extreme heat, that is known as terminal heat stress events will be more, terminal heat stress events will be observed. Increased insect infestation, okay, and shift in, I have already told you, climatic extremes with respect to rain, precipitation patterns will be, flood, drought will be there. So they will have consequently effect on the agriculture protection. So these are the, then more soil erosion will be there. Then it will, human health will be affected. So these are all the negative effects of the climate change. And with all this positive and negative impacts, there is projections, the studies has been carried, modeling studies has been carried out, and they projected the losses in food production due to climate change by 2080. And you can see the different color codes will help us in deciphering that how much shift in food production will take place in that region. Then if we will come to the India, that it has been projected that in India by 2080, there will be 50% reduction in food production. Okay, and in the temperate, the green color indicate the temperate region, there will be gain in food, up to 35% gain in food production has been projected. And with respect to India, different crops also, the scenario which we have observed at planet scale, the same scenario is applicable with respect to different type of crops, like those rice, wheat, maize, and sorghum crops productivity got declined, whereas the gram, soybean, onion, and castor crops productivity will be enhanced. And there will be like potato, groundnut, coconut crops productivity will show a mixed response. So in this way, we have seen that the climate change direct effect, indirect effects, and social and economic effects has been established. And now we have to find out the solution. So what should be the plan of action and research priorities? Typically, what managers they do, they recognize the situation, which we have already done, that yes, climate change is affecting our food production system. Then we need to identify the solutions. And out of those solutions, we need to prioritize that which options we are going to choose first, or which options will be most suitable for that reason. And for recognizing the situation, I have already done you. We need to do the vulnerability assessment. And after vulnerability assessment, this is the vulnerability assessment. We need to find out the adaptation strategies and mitigation options. And then we need to find out that at which location that strategy will be most region specific adaptation and mitigation strategies we need to find out. And this is that the agriculture in UNFCCC, every country is committed to reduce its emission from. So as I have told you, agriculture is also contributing to GHG emission. So we need to find out the mitigation strategies to minimize that emission. But in that, India is only intended nationally determined. We call them intended nationally determined contribution. We need to reduce that. But we have adaptation. So India has given priority over adaptation. We have not opted for mitigation. Whereas this red color code countries, they included that they will try to mitigate the emissions from their agriculture sector. So, but though we have not committed, we have only voluntarily committed to minimize those mitigation, but we have done our vulnerability assessment of agriculture to climate change. What will be the, with respect to different states as well as up to district level. We know that which districts will be more vulnerable to which districts agriculture productivity will be affected very high by the climate change and which districts agriculture productivity will be affected very less. And this, we know that I have already told you, the vulnerability is the function of the exposure, sensitivity and adaptation capacity. So if we want to simplify, then it will be impact of climatic condition minus the adaptive capacity of society. So it is not only on the natural status of the resources which are available in that region, but the society's capacity will also influence it. And the adaptive capacity of society is dependent upon the technology, resources, infrastructure, human capital, and well-developed institutions and equity. And with this, the adaptation strategies and agriculture and food security with respect to climate change, which has been recommended, are the use of improved crop variety. We should have pest risk analysis and improvement of pest management techniques. We should have a more robust crops and livestock breeds for drought and pest tolerance. And there should be awareness creation on climate change and adaptation strategies. We should have strengthening early warning system, and in that remote sensing plays a very crucial role. And then research on pest resistant varieties should be more. Then improved assessment tools for forecasting migratory pests, including integrated crop and pest management. Then better use of climate and weather data for weather forecast, and improved soil and water conservation measures and water harvesting. So thinking mitigation and adaptation is not enough. Fundamental transformation is needed towards bioeconomy. Transformation of whole economy to sustainability means we need to now not only focus on the profitable economy, but we need to shift our focus towards a sustainable economy. And when we will do that, then only sustainable food system and rural urban links will develop. We need to develop biosensitive cities, and we need to ensure sustainable consumption patterns. So in that way, then only we will able to, what happens, the developing countries aspire to developed countries, and those countries which are developed now, they are aspiring to climate smart development. So now we have to forget this route to aspire as a developing countries. Now we have to aspire as a climate smart development country. And for that, we need to identify the technologies which are based on low carbon, low water consuming, low nitrogen consuming, low energy consuming, as well as we need to also keeping our profit low but sustainable. And we need to compromise less the interest of stakeholders. So with this, I just want to thank you all for giving me opportunities. And if you have any questions with respect to my topic, then they are welcome.
Thank you so much, ma'am. That was great listening to you, and so many new perspectives also we got to know. Thank you so much, ma'am, for gracing us. And there are a few questions, ma'am. Would you like to answer?
Yes, please.
Some of the global data analytics point fingers at India as one of the top 1 or 2 in terms of food wastage, production,
Just a minute.
storage.
I am not able to see my screen. Just a minute.
Okay.
Okay, just a minute.
Ma'am, you could unshare, then it will be visible.
But yeah, unshare bhi nahi ho raha hai.
At the top, ma'am. The unshare will come at the top.
Okay, just
yes, ma'am.
It's okay. Yeah, thank you.
Ma'am, can you see in the question and answer also that it is
Just a
there?
minute.
Yes. The question is, some of the global data analytics point fingers at India as one of the top 1 or 2 in terms of food wastage. So is it true? How can we reduce methane emission in paddy fields? That's another
Just
question.
a minute.
So the first one.
How can just actually the questions are not visible to me. Could you please repeat the second? What is the second question? How can we mitigate the emissions from paddy fields?
Yes, that is the second question.
Okay, actually, for that, the mitigation strategies which has been recommended for rice, methane emission from rice, is that now the new technologies for rice cultivation has been recommended, like systematic rice intensification technology is there. Okay, and then DSR technology is there. In that, the conventionally the way rice has grown is that the field kept flooded, that is known as puddling, and then in that seedling has been sown. But that puddling itself is responsible for the emission of methane. What happens that whatever organic matter which is present in the soil, that puddling create anaerobic condition, and under that anaerobic condition, the organic matter gets reduced and it will be released as a methane. So that's anaerobic maintenance of that anaerobic condition has been avoided. So new technologies has been recommended for rice cultivation, like systematic rice intensification and DSR technology, in which direct seedling has been sowing, so that puddling has been avoided. Okay, so this is the new. This is the way. This is the mitigation strategies which has been recommended to minimize the methane emission from paddy fields. And next question, what was that?
India is supposed to be at number 1 or 2 for food wastage. So is it true?
No,
that was the question.
No, we will not generalize it as a India. Actually, it is when it will be compared within state-wise also. In some states, the food wastage is very high, where in some states, like if we will say Sikkim, which is following the whole organic state, and in that state, the society is so conscious that they are avoiding even food wastages also. So we cannot generalize it. It is a individual, but I am not aware of any such data in which it has been. But then we have to see that what are the attributes they have considered to come out at that value. So we need to validate that thing also.
Thank you, ma'am. Thank you so much for gracing us. And it is actually very beneficial for our students to learn from your experience. Thank you so much, ma'am, for joining in.
Thank you.
Thank you, Dr. Isha, coming and
you.
joining us and giving you a deliberation. I hope that students will have a lot of knowledge out of the topic which you said, relating it with the climate change and food security.
Thank you.
Something new for the research also and for the discussion further. Thank you very much.
Thank you. Well.
Thank you, ma'am.
Thank you.
The next speaker we have Dr. Madhuri Kumari. She is Professor, Department of Civil Engineering and Deputy Director, Placement and Industry Relations at Amity School of Engineering and Technology. She has vast industry experience of 11 years and academic experience of around 11 years. Her research work is in area of rainfall modeling have been published in reputed journals. Her research interests include data analytics, application of geographic information system and remote sensing for solving engineering problems, water resources engineering and management, hydrology, hydroinformatics, irrigation engineering. Her topic for today would be spatial decision support system, an effective tool for understanding human environment response. Madhuri ma'am, we are very happy to welcome you today.
Thank you, ma'am. Thank you so much.
And we would like to felicitate you with a virtual Tulsi sapling. Dr. Ashutosh Tripathi is welcoming you with a virtual Tulsi sapling.
Thank you so much.
Thank you, ma'am, for joining in. It's a great pleasure to see you, and we are very eager to hear from you, ma'am.
Thank you so much. So may I share my screen, please?
Yes, ma'am.
So if you could please confirm that screen is visible, and
yes, ma'am, it's visible.
Yes, ma'am, it's visible and you're audible. Welcome, ma'am, and good afternoon, ma'am.
Thank you so much, and good afternoon to everyone. And thank you so much, Dr. Richa ma'am, for doing this honor of introducing me. It was indeed a detailed introduction, and I'm highly privileged. And it's actually a very, I would say that it's a great opportunity given to me to be part of this very, very relevant workshop in this era. The topic which has already given by Dr. Richa, and the topic that I'm going to be talking on is spatial decision support system, an effective tool for understanding human environment response. Before I start, I would like to put this on record for the workshop organizer. A big congratulations and thank you for this wonderful workshop on climate modeling and remote sensing application for environmental system. Very nicely, all the topics of the sessions have been very deliberated very nicely. And the session that we are witnessing at the moment, my dear participants, it's around understanding of the human environment system, climate change research, responses, and thresholds in Earth system. I would thank my speakers who have actually spoken before me, and they have covered a lot. And I think I'm kind of going to echo a few of the aspects that has been discussed by my previous speakers, and more so by Dr. A.K. Lohani, who was also talking on spatial decision support system, followed by Dr. Gaurav, who also tried to talk on the decision support system for air modeling. So how is my talk going to be different from theirs is only that I'm going to be focusing more on the technology aspect rather than the entirety of the system and the application of the system. So by that means, I just want to focus on the use of the technology, the different aspect of the cloud technology that is available in today's era, which can give an advantage to us when we talk about developing a spatial decision support system. So with that, I would begin my talk. The flow of the presentation would be environment, human response, and the geospatial technology, followed by that a small introduction on decision making and the DSS aspect. Then what is spatial decision support system, and moving on to the web version of it, which is ESDSS, followed by a case study on which I, along with my team, have worked on designing a spatial decision support system. So again, something very, very general and very obvious. All of us knows about it. Why do we conduct an environmental study? So of course, from the point of view of scientist and researcher, we try to explore the environment to mainly try to understand and collect the knowledge or build a knowledge pertaining to the environment, to understand its process and linkages with the human or other ecosystem. What are the main objectives of our environmental study is, of course, when we talk from the perspective of being of a scientist, so gathering data pertaining to the human, it is about gathering data pertaining to the environmental phenomena, to explore environmental process via empirical investigation, to develop theories, and of course, the most important part is to design the mitigation measures for the identified environmental issues. So of course, we are actually focusing on the environmental study. Basically, it is to gain understanding and the insight into the environment. And of course, here we are going to gauge the environment and human response. So why are we talking about environment human response, and what are we aiming to achieve at when we talk about the response between environment and human? So basically, the target is to prevent the environmental deterioration and degradation. So that has been already spoken by my previous speakers. So if I have to be talking about today's workshop, so if climate change is one aspect of it, so of course, when we are talking about environment human response, we are trying to understand how this climate change is going to really impact human, what is the contribution or what is the anthropogenic action that is leading to climate change, and thereafter we would look in for mitigation. To prevent the overuse and exploitation of natural resources, primarily nowadays we are talking about SDGs. So to promote the sustainable development, we need to understand environment-human response, and then to preserve the biodiversity of the environment and bring in the balance between different components of the environment. So primarily the objective of such study is to understand and mitigate the impact on the environment, both by the anthropogenic action, or it could be direct or indirect one. So ultimately what we are doing, we are actually trying to build our focus around environmental impact assessment study. So there we are talking about a decision support tool, basically around the environment, which provides information of the impact of this project, and we are trying to give this impact or show this impact to those who can take decision of whether such project has to be coming in place or it need to be discarded. So we, from environment human response system, we are actually moving on to a tool which will help us to make a decision, and such tools are a tool. One of the tool is EIA, which is, again, we are talking about a decision support tool. So now coming to the technology through which we can actually build such kind of tool, powerful tool, I should say. I mean, all the speakers till now have been pointing out the power of spatial decision support system. So geospatial technology, which is nowadays present everywhere in all domains, we are talking about geospatial technology, and more so picking up from the today's workshop title, remote sensing application. Why are we talking about it? Because it's now a known fact. We can shout out to the world that this is one technology which is going to be very handy in the coming days. So in that line, I have also picked up this geospatial technology to talk on the building up of tool for gauging the environment human response. So again, all of us know geospatial technology is helps us in managing the data, characterizing, understanding, and assessing the data, trying to model the data and do some kind of analysis, forecast, understand how it is going to be today, tomorrow, how was it yesterday, and then from there, look out at a management strategy and which can help us or support our decision-making capabilities. So geospatial technology is a support platform that can integrate environment characteristics, human action, and thus it could lead to a visible response. So that's the power of geospatial technology. So I would actually call it as ultimate application of geospatial technology is to support the decision for decision making. Again, here I'm echoing Dr. Lohani's sentence that it is not a decision making, it actually is not going to make a decision for us, but it is going to support us in making decision by showing us different alternatives, by giving a visualization aspect of the human action and its impact on the different parameters of the environment. So by that, we can actually use it for the decision support system. So when we talk about geospatial technology, just try to pick it up from the source MAPA Limited. Very well, it shows like how geospatial technology is all across, it is being applied across many disciplines, professions, and organization. So coming to geospatial technology and decision. So would just recap, I have explained the environment human response. How can we capture it? The technology that comes in is geospatial technology. And now we are moving on to geospatial technology and specifically about how it can help us in decision. So GIS and computers can use the data that has been collected by us and perform various types of analysis and modeling. So again, it helps us in performing the same. But of course, the decision is not by the geospatial technology, it is by the people. So we are going to look at like how it helps us in making the decision. So that's the second part of my discussion, decision making and DSS. As already mentioned, again, we are trying to say what's the difference between decision making and decision support. So decision making requires intelligence. It requires design of various decision alternatives, and then ultimately the choice between these alternatives. That is Simon's model, which is one of the famous model when we talk about decision making. So GIS is not a decision making tool. It allows us to make a good decisions, because we know for good decision, what do we need? We require knowledge and foresight, insight and intelligence, and of course expertise. So since these are the characteristic that is required for making decision, we understand that software or a computer or a hardware will not be able to do this, because they would have something called as synthetic knowledge, but not a natural knowledge, a synthetic expertise, but not a natural expertise. So it would help us in making a decision making by doing several analysis, giving us different visualization aspect of different alternatives. So GIS does not provide what I have mentioned about the decision making, but yes, it can fulfill important role in decision making, and hence the decision support process. So what it uses is different input, different opinions, provides different alternatives, provides different site selection scenario, and allows us to analyze different if-then scenario. So this DSS is computer-based system. It would have a user-friendly user interface. It allows us to define and study area and the application area. It allows us to input different data. It allows us to conduct modeling and analysis. It is an interactive system which allows us to queries so as we can get answer to different questions that we have. It allows us for different data visualization and representation. So there we move on to the spatial aspect of the simple DSS concept. We add spatial to DSS, it becomes spatial DSS. We are using geospatial technology, capturing the spatial aspect of the data, modeling the spatial aspect of the data. So SDSS is nothing but it adds the spatial aspect to a general DSS. It supports spatial data input. It stores complex structures which are common in any type of spatial data, and it uses different analytical techniques which is unique to spatial data. And of course, the output is map visualization, cartographic output is what it gives. So that is how it stands out from a simple DSS. You can see the components of SDSS. GIS is the heart of it, of course. Model, database, storage. Model is to play between the data that has been collected. Data is being stored in the database, and who gets to know about it is of course through the user interface, the interface which is provided to interact with this GIS system. And of course the decision making is by the user who has the expertise as well as the knowledge. So what is SDSS doing in terms of helping us to understand the environment-human interaction? It allows us to collect the data and feed it into the system. Allows us to do the custom data filtering. You know, we can actually hide the data which we don't require. We can play with the data. We can query only from the subset of the data. The identification of hotspot areas, you know, the area which needs real focus. Then visualization of various alternative site selection can be done by SDSS. Different types of information based on the data collected. And also it allows for the public to participate through crowdsourcing. And then it allows us to do some kind of decision by doing various inquiry on the data and the maps that are being visualized through the SDSS. Now we are moving on from a simple spatial decision support system to the E version of it, which is an online version. We all are, I think nowadays we all know what we mean by online version system, being locked to a desktop may not be a good solution, because we want to access the system from anywhere, anytime. And that's what SDSS answers. It gives an online version of SDSS. So it is a web version of DSS. It allows the public participation, and it utilizes the internet resource for rendering this the various activities which can be done through SDSS. Again, I would refer back to Dr. Lohani's the kind of system that they have come up with for water resource management, and he was showing various menus and various options that are available, and it is going to be available over the internet. Of course, it is going to be protected by login, user ID, password, but yes, that is what it is. It would be made available over the web. So this type of GIS application, which is over web, can be used anytime and anywhere. It can be used on the through the smartphones, on any type of operating system. So that's actually a beauty of moving this SDSS from being desktop logged or client logged to a web version of it, which is nowadays being practiced. Now, what is that? You know, every time when we talk about a system, we are very much worried about its cost. We are very much worried about the license system that we need to really be banking on. But now this slide is mainly, again, the sources, the MAPPA Limited. I have picked up from there. It is trying to show to you that a lot of open source has come up in market. There are free APIs that are available. Open web standards are available, which can help you develop an SDSS. So it is not going to be so cost intensive, but it would be cost effective. So now you can develop an SDSS, which can be hosted over the web at a very cost effective mode. Reason being, you have all the technologies which are available as part of open source. So the general GIS, web-based GIS architecture would be that you can see here 3 layers. From the starting front, you can see this the layer which is available to the user through the web browser. The user can go and access that web-based GIS. In the center, you have the server, which is going to really process the request, the business model, as well as the logic, business logic. And then at the back end, the last layer that you see is the database layer, where all the data is going to sit. And the data is being pulled out from here by the central layer, wherein the data will be analyzed, and then it will be passed on to finally the user in the required format. So that's the basic web-based GIS architecture. On the user end, you may have user who is particularly having the rights of web or manager, and or they may be an information feeder. The user may be the information feeder. So there could be multiple types of user which can be supported, and that is all login based. Now I'm coming on to the latest technology that is available, where again, I was talking about cost effectiveness. The cost effectiveness is in terms of the software, yes, and also in terms of the hardware. Now, why do I talk about hardware? We all understand when we have to develop a software, we need to host it, we would need infrastructure for that. The cloud has come up as a replacement for that physical infrastructure, where the virtual processing center can be set up and all the data can be managed in the cloud. Now, GIS has a special arrangement of the service models for the cloud. It could be the GIS as a service, or it could be application as a service, or it could be imagery as a service. So the cloud can be used, and the service model could be in each of them. So advantage is that, you know, you pay as you use. You're not required to have a space and buy your infrastructure, but you design your system in a way that you have to just shell out money based on how much you are using. Different types of cloud models are there. Private cloud, where only single is going to use. Again, if we are talking about defense-based SDSS, it would have a private cloud because security issue. The public cloud, if there is something which is not really so secure and it could stay in public, then you use a public cloud. It is cheaper than private cloud. There could be community cloud, which can be used amongst the organization, and there could be hybrid cloud where you have few space like lockers, which are specifically private, and you have other space which are public, which could be used by everyone. So that way you save the information which are secure in the private space, and others could be placed in the public space. Again, these are all models to design a cost-effective solution. So here the cloud provides a cost saving. Apart from the open source that is available, the cloud is one aspect that we could consider for cost-effective solution of SDSS. The cloud offers saving in terms of capital cost because you don't have to buy hardware. You need not invest in it. You save space because you have no hardware, so no worries about where you have to place your hardware. You don't need trained personnel to maintain that hardware. You pay only per use, how many transactions, how many query you are doing, what is the size of the code you are going to store, what is the image you are going to store, and you have an integrated backup. That's a feature of cloud. It is not that if something goes wrong at the back end, you are not having the data available. The backup is the headache of the cloud provider. So that again, there you are having you are safe. Mobility, which means you are able to access your data from wherever you are. You have unlimited storage capacity. It is like elastic. Tomorrow you think you need the second database, you buy it then, rather than buying two database or too much of drive space upfront. You buy as you want. Okay, and there is high reliability because there is integrated backup and restoration. Finally, I would quickly go through the case study. And this case study, I would like to acknowledge the MOEF funded project on development of GIS-based decision support system. PI being Professor BKP Sinha, and co-PI along with me, my other team members were Dr. Amrina Sardar Khan and Dr. Prateek Srivastav. We made an attempt to design an SDSS, though it's not as intensive as Dr. Lohani was showing, but yes, it was an attempt to showcase that the data that are collected across, it could be collected anytime by anyone, but it could be integrated and placed at a central place. And whoever wants to look at it would see the latest or the real time basis, what's going on, where the data is getting collected, how it is being updated. And then later on, there was provision of looking at the data and analysis of the data, and finally trying to use the visualization of the data presentation for making certain decision. So I will present a generic aspect of it. So if we take any environmental issue, now it would have two basic components, spatial and temporal extent. It requires an understanding of anthropogenic action and its impact. And then finally, it requires a mitigation. So mitigation would be better if we can visualize the issue. We could collaborate with the people, and if people could also provide data or information related to the issue. So that results, that could be answered using decision support system, as it can actually provide a platform to integrate vast data of different domains, and also give different types of answers to different types of queries by different stakeholders. When I say stakeholder, public, as a public, as a citizen, I may have a separate query when I look at the particular issue. As a politician or as a decision maker, I may have a different query. As a scientist, I may have a different query, and that is available through the decision support system. And the system has to be, of course, a low cost. So when we talk about low cost, we talk about not a licensed version of the software, but we generally opt for open source. That is what we did in our project. When we talked about mitigation measures, and this is how we came up with SDSs, as we wanted to look at an interdisciplinary and collaborative approach. So now various stages where GIS and remote sensing application was involved in development of SDSs. Data collection was done and GIS based mapping of those collected data was done. Different sources, point sources and data was all mapped on the map. Remote sensing was used for collecting different digital images. So image processing was done and different analysis of these images was done with respect to the collected data. The modeling of using the data, the dependent and independent variables. So different types of algorithms was used to conduct the geospatial modeling and to analyze which what was performing the best. And thereafter, these all things were integrated inside a decision support. This is a basic architecture of the system that we developed. Graphical user interface on the left-hand side that you see, we had two user interface. One was web-based and the other one was mobile platform. The input and the output both was visible. So input, you could do it from the web or you could do it from mobile platform. And the output you could visualize in the form of a map or in the form of XLS or CSV, which you could get either from the map or even from the mobile platform. So the data was all stored in the database, and GIS was used for spatial analysis. The files were in the format of Excel files, tables, or printed copy, and the inputs that were used were spreadsheets, sampling and collected data, and the satellite images. This is the representation of the portal that we tried to develop. The one layer, the topmost layer, which is SDSS portal, followed by a middle layer and the repository that was core SDSS system. The top one, the user interface was both mobile user as well as browser, as I mentioned. And the component that were actually available after different analysis was actually stored on Amazon Cloud. We used AWS. And the UI layer, we used mobile app for Android and AngularJS and Leaflet for the portal. And backend layer, that is the business layer, was again in Node.js. We used Amazon Lambda and Amazon Cognito. And for data layer, we stored the images and files in Amazon S3, and all the other data was on Amazon RDS. So that's the complete, a very quick overview of how our system looked like and what was the technology that was used. So overall, again, multiple channels, users and interface. So we had mobile application as well as web application. Technology stack was all on open source software. There was no money that was allocated for the software development part. We used all the open source software. Native mobile application for Android, AngularJS was used, Leaflet library was used. For authentication, we use OAuth2 module. REST API was used for both the business logic as well as for showcasing the user interface. And object storage for static component like map files was used. Hosting was done on the Amazon Cloud Service Provider, as I have already indicated. And this is the cloud service provider, which is empaneled by MITI. So that is how we have picked up Amazon Cloud. Then a Lambda function, Amazon RDS and Amazon S3. These were few options of Amazon that we have used. These are few screens. This is actually of a mobile application where you could log in and then look at the data that has been collected, or while on the go you are collecting the data, you could enter the data that you are collecting in the field, and the others could see because it is going on to the central server. This is a web-based portal which we developed, which was actually login based, and you could see the data that is being entered from different sites. The data visualization was available by integrating it with the map. Different versions of maps were used. And then there were various provisions of looking at the analysis of the data, the hotspot, the different indexes. And once that analysis was overlaid on the map, there could be further decision that could be taken. So that's about the SDSS that was developed by us. So that's all from my side. Thank you. And over
so much, ma'am. Thank you. It was really engaging and we learned a lot of new techniques and how it works. Thank you so much, ma'am. There are a few questions. Would you like to answer them?
Yes, yes, please.
How Web GIS is different from Web DSS?
Okay, so the answer is to that is, Web GIS, if it is not allowing you to take any decision or, you don't have models integrated into it, then it could be a simple Web GIS. When you have a model which could help you in decision making, where on the go, if you could manipulate or you could model the data, you take the data and then you can model it and see the model different alternatives coming in, then that is specifically a DSS capability. So if you have this capability into it, then you call this Web GIS as DSS. But as such, when you go by the nomenclature, it is not so different. Yeah, it is just that I call my system as DSS because it allows me to take decision and it is focused around it. It is focused around supporting the users or the stakeholders to make decision by choosing various query parameter. So it will be a query intensive website and modeling would definitely be part of it. So that is Web DSS, and Web GIS could be simply about showing the spatial aspect of it. For example, if I have to take an example of Corona's extent and how it was all spread over. So if you see internet version of this information that is being available, that could be a simple Web GIS. It is not allowing you to do and make any decision, right? It is just showing some information to you. If you have to see how your flight is moving from one point to another, and if it is available over the internet by going to a website, that is just a Web GIS. You are not able to take any decision. But if you have a component of decision that is integrated into it, where you can actually go and see and ask from the system, okay, show me all the points where the temperature has gone up by 2 degrees Celsius in last 2 years. If this is what you are able to do on your web-based system, then that is more of a Web DSS than just a mere Web GIS. So that's a basic difference.
Thank you, ma'am. Thank you for answering it. There is another question. What are system integrators in cloud computing?
I did not get the question. I'm really sorry.
Ma'am, in the question and answers, it is, what are system integrators in cloud computing?
So I'm not pretty sure about what it is indicating to, but again, as I mentioned, the cloud computing, there you use the platform cloud, and the service models that are available are in different mode. If I don't talk about GIS, but a simple cloud based system that we have. So we have a platform as a service, we have infrastructure as a service, and a software as a service. So that's about the service model of the cloud. So I'm not sure about what is the meaning or what is the user indicating by asking system integrator.
Thank you, ma'am. Thank you for answering the query. And
Dr.
there is another
one more question. There's another question.
Can you please, could you please mention
topic
some?
is so much relevant that there are a number of questions we are getting in the chat box. So if we have a time, then we will ask the third question, ma'am.
Yeah, sure. I think this one I'll try to answer.
Should I read it out, ma'am? Could you please mention some practical projects which could be fitted by SDSS for human responses? Can it be map mindset of people in elections and politics as well?
Dr. I have been seeing that you're very active, and
I was also about to say the same.
Yeah, a lot of questions coming in from your side, and the days are not far with this artificial intelligence and machine learning in place. I think it is not really far off to mindset of the people. But of course, at the moment, if you ask me as an individual, I may not be able to indicate application which is available upfront where you can see the mapping of the mind. But yes, there are a lot of works going on already, and such type of questions that you are asking would definitely be part of it. We are already witnessing when there is report on elections that comes in, where we are trying to analyze the different data that is collected by the people and around the elections, and the past data being collated. From that, they are trying to indicate various forecasting. They are able to do various forecasting. So I'm sure that in days to come, we will also be looking at this. I mean, how do you think it is far off? Because Alexa is already there. It is reading your mind, trying to show you what you want to see. So that's the thing. Yeah. But yes, geospatial aspect, maybe we'll have to wait for it. It should be there. Yeah. Thank you.
Thank you, ma'am. That was very interesting. And thank you so much for deliberating on all the queries of the students and of the participants, I would say. And thank you so much, ma'am. It's so enjoyable to hear to you.
Thank you so much. Thank you once again to Dr. Ma'am and Dr. Amrina ma'am specifically for following up with me and giving me this opportunity and slot for sharing whatever we have learned. Yeah, thank you once again.
Thank you so much, ma'am.
Thank you, ma'am. And now we have with us Dr. Pallavi Saxena, Assistant Professor, Department of Environmental Sciences, Hindu College, University of Delhi, Scientific Steering Committee member also of IBEEPS, Advisory Board member, APSI, USA. Her area of interest is air pollution, trace gases, and aerosol chemistry, and impacts on plant and human health, and working in this area from last 14 years. She had also successfully completed her tenure as chair of South Asia and Middle East region of Early Career Scientist Network of ILEAPS Community, UK from 2017 to 2021. She has also been awarded Jawaharlal Nehru Doctoral Scholarship, CSIR SRF Young Scientist Award, ISPP DBT Biocare Award during her research career. She has published more than 30 research papers in high impact factor journals. She is also an active participant and co-author of TOR Community USA since 2015. We are very happy to welcome you, ma'am, and she'll be speaking on the topic health benefits due to reduction in fine particulate matter by using air quality health models during COVID-19 lockdown in India. Ma'am, we would like to felicitate you with a virtual Tulsi sapling. Mr. Naresh, yes. Dr. Manoj Chandrakar is offering a virtual Tulsi sapling to Dr. Pallu. Ma'am, we are very happy to welcome you and eager to listen to you.
Thank you so much. So thank you very much to invite me and to give me the opportunity to share my experience on the new dimension of the climate change, that is the interlinkage between air pollution, climate change, and COVID-19. So just give me 2 minutes. I'm sharing my screen. I hope the screen is clear.
Yes, ma'am, it's visible.
Yeah. So today I will discuss the new aspect of the climate change, that how it is linked with the air pollution and how it is linked with the COVID-19. So as you know that we are living in the COVID world, and there are many advantages and disadvantages in different aspects due to COVID-19. So in this talk, we will discuss about the that how air quality changes affect the climate in a positive sense during COVID-19 lockdown in India, and how air quality health models help us to evaluate the health benefits due to the reduction in the air pollutants. So as you can see in this slide that there is a connection between the COVID-19, air pollution, and meteorology. So air pollution is one of the factors that is responsible for the climate change and emergence of some diseases. And that has a vital role in the vulnerability of infection. For example, if we are taking the example of fine particulate matter, that is PM 2.5, that is found in air. So many of the studies have shown that they have the direct transmission mechanism for viruses like COVID and related strains. So many studies have reported that exposure to fine particles could enhance the clinical manifestations of infected people and affect the susceptibility of individual to the infections. There were two sides of the relationship between COVID-19 and air pollution and meteorology. So some air pollutants like PM, that is particulate matter, and ozone tends to increase the COVID-19 cases. And whereas the lockdown period are just like a gift for us for the in with respect to the air quality, because they tend to decrease the air pollutants also and the short-term global temperature also. So this thing will act as a base and as a theme to think about in the future. Then with this concept, if we go with the short lockdowns, if we go for the, we go towards the sustainable development, that if we go in the future for the short lockdowns, then the air pollutant levels can also be decreased. Then there will be health benefits also, and we can move more towards the green development. So now this is an image which is showing that how particulate matter has a major role among the air pollutants in the COVID-19. So fine particles exposure could enhance the chances of increased severity in case of COVID-19. Suppose if a person is infected with some respiratory disease, and that is due to the air pollution exposure mostly. So it has a more oxidative stress and more on inflammation. And when this person is being affected with the COVID-19, that person is become more prone towards the mortality. So many of the studies have reported that. And the infected person can also be act as a source for the infection, because whenever it sneezes, whenever it coughs, then some of the particles can come out and can deposit on in the indoor and the outdoor environment and can act as a transmission vector basically. So in this picture, as you can see, there is a specific thing that is ACE2. So this ACE2 is angiotensin converting enzyme 2 activity, and its main role, if there is some contamination in your lungs, then this enzyme has the role to reduce that contamination and prevents the lungs from the damage. Fine. But when the COVID-19 acts on it, then what happens? It inhibits the activity of this enzyme, and apart from it, the particulate matter enhances this process. So the infection increases along with the particulate matter also, and along with the COVID-19 also. So that's the thing. So these are some of the studies that are there from the different parts of the country, mostly the Asian countries, where there is decrease of the air pollutants, except you can see in case of tropospheric ozone. Only in case of the tropospheric ozone, there is increase in the concentration, because might be due to the increase in the volatile organic compounds, because ozone has so many precursors in the environment, like VOCs, like NOx, and the VOCs are being emitted from the trees. That's the basic source, that's the biogenic emissions. So during lockdown, this is the only air pollutant which is increasing in mostly in all the countries because of the increase in the biogenic VOCs, probably. So on the note of the reduction in the particulate matter that reduces the risk of the human health disease, that is COVID-19, and a good solution of the climate change also, we have done a small set of study, and that is published in a high impact journal, that is Aerosol and Air Quality Research. So this study will act as a base for the policy makers that short lockdowns during the selected periods in future can act as a sustainable solutions and for the climate change, and improving the health condition of the people also, and reduce the air pollution levels also. So the objective of our study are to quantify the health benefit during the lockdown in India. And in particular, we assess the particle deposition in the tracheobronchial region, that is a region inside the human lungs, and mortality before lockdown and during lockdown phases in the year 2020. So first, when the lockdown has been imposed, so we have selected 2 periods, that is before the lockdown and during lockdown. And we have taken 2 years, 2019 and 2020, just to have a comparison in the air pollution reduction. And we have taken the specific pollutant, that is PM 2.5, that is a fine particulate matter, because that particular air pollutant is responsible for the human health disorders, especially the respiratory disorders. That's why we have selected it. So the assessments were based on the temporal variations in PM 2.5 concentrations in 4 non-attainment cities of Uttar Pradesh and Delhi NCR. So in this map, 4 NACs, that is a non-attainment centers, have been selected in Uttar Pradesh, namely Agra, Kanpur, Lucknow, and Varanasi. And apart from that, we have selected the Delhi NCR. So in terms of the population density of Delhi has largest and Noida has lowest. So this is the timeline of the COVID-19 lockdown. So these are the phases that starts from phase 0 to phase 4. So phase 0, we are remarked it as pre-lockdown period where there was no restriction. And phase 1, when the lockdown just started from 25th March 2020, where all transport, industrial establishment, commercial and private establishments were closed. And in phase 2, that is where farming operations, some industries and movement of cargoes are allowed. And in phase 3, where the cities have been categorized into different contaminant zones, that is red, orange, and green. And there are relaxation of many rules are there. The movement of vehicles are permitted. And in phase 4, where the movement of vehicles without any special conditions are allowed. So we have taken the data from the Central Pollution Control Board of New Delhi and from the UP of PM 2.5 for 24 hours of year 2019 and 2020 of Delhi NCR and UP. And for the calculation of the health benefits, that what is the accumulation or what is the reduction in the particulate matter inside the lungs, that is in the tracheobronchial region of the lungs, we have taken 2 models, that is AirQ plus and MPPD model, that is a multiple path particle dosimetry. Now, AirQ model is used to estimate the change in mortality attributable to particle inhalation. So that is the role of AirQ plus. And MPPD is multiple path particle dosimetry. And this is a model which is used to calculate the mass of respirable particles deposited in the tracheobronchial region. Means if you want to calculate the exact mass, the exact reduction in the particulate matter which is being deposited in your lungs, then you can use MPPD model. And if you want to calculate what is the mortality rate, what is the change in the death rate, then you can use the AirQ plus model. So these are our result, and this graph is showing that Px by P naught ratio, where Px represents the mean PM 2.5 concentrations during phase X. Now this phase X can be 0, 1, 2, 3, and 4. And P naught is the PM 2.